the technology. Given the excitement that's happening around machine learning and artificial intelligence out there in the world today, we're really at the industry's AI moment. I'm not surprised if there are a bunch of new faces here. So today and tomorrow, we will have sessions on building enterprise scale MLOps deployments with a demo of a real world financial industry example that we've done with some of our customers. Training large language models and various approaches that users can take from training from scratch to starting with pre-trained models and fine-tuning them and exploring some of the other techniques available there. We'll be talking about batch inferencing using other open source libraries like Hugging Face transformers and advanced parallelization techniques using DeepSpeed. And we'll be talking about AI reproducibility and transparency by managing model training data. We'll be talking about end-to-end machine learning solutions in a demo deploying computer vision over large areas of satellite imagery. And we'll be leveraging large language models in production by customizing some of these off-the-shelf LLMs models with domain-specific data. And we'll also have a bunch of open Q&A sessions on machine learning technology and infrastructure, as well as the algorithmic and kind of more data sciencey techniques that are being applied out there in the field. So we've seen really rapid acceleration and innovation in ML over the last couple of years. And as someone who's been participating in this industry for 15 years, the last 2 years have been absolutely it's clear that we are still facing massive challenges in scaling machine learning, in offering reproducibility, and moving machine learning into production. It's more art than science, and it's more science than classical software engineering for sure. Now, machine learning also, as if anybody's been paying attention, is requiring even larger and larger amounts of compute resources, and this has led to real infrastructural difficulties for many organizations. And it's a trade-off. We get amazing experiences. We get generative models that can produce art that nobody's seen before. We get large language models that can oftentimes pass the Turing test. But it comes at a cost of computational resources, and it's increasingly gotten to the point where managing those computational resources and making sure that we're putting good behind our investments there is really, really important. So we're aiming to help the community address these types of issues in sessions in this conference. Now, this event is organized, as I mentioned, by the open source community team, working on Determined AI and Pachyderm and some of the other technologies that we have here at HPE, with guest speakers from across the community. Now, Determined remains an open source machine learning training infrastructure platform, but and Pachyderm remains an open source platform for data management, data lineage, and versioning. But we fully recognize these are components in a much larger ecosystem. And we really believe firmly at HPE that open source is key to solving many of the challenges that machine learning faces, providing transparency, interoperability, flexibility. And proprietary models and limited license models really, we feel, pose a danger to slowing down ML innovation. Some of the largest players in our industry have leaned away from open, unfortunately, and have chosen to say, you know what, we're going to stop publishing papers, or when we do publish papers, we're going to stop talking about the techniques that we're using to achieve innovative results. And that's unfortunate. It's important. I understand the strategic challenges that some of these companies are facing and the arms race that they're in. However, I don't think that secrecy is a long-lasting technical moat. It's not a long-lasting business moat either. And if anything, we as a community really need to come together to democratize the tools and techniques that we're using to approach solving these important challenges. At this inflection point that we're all living through right now around AI becoming the next internet or the next mobile or whatever the right analogy is. We need to be helping each other and setting standards across the industry around how do we deal with these challenges we face when we're scaling. How do we construct the right open stack as we're developing our ML platforms? And so we really convened this event to chart a path forward. We're providing open tools to scaling ML, and this is supported by open source and an open community. And we're excited to be talking to you about these important topics today. And we hope that people will get a lot technically, and more importantly, get a chance to interact with peers that are facing these very same problems and understand how they're solving them at their organizations so that we can all make forward progress together. So in addition to our interactive platform here that you're all on right now, we're also streaming live on YouTube, Twitch, LinkedIn, and Twitter. So I guess that last one is called X these days. If you're unable to attend any of the sessions, they will be made available later on YouTube. And I encourage you to please join our community Slack, that is the Determined Community Slack, and follow us on YouTube. The links will be in the chat below, and really encourage you to take the next couple of days, listen to a bunch of talks. If you don't have time, make sure to rewatch them if they're of interest to you. But join the community and get involved and get involved in the conversation. So with that, I welcome you all to Machine Learning at Scale 2023 and look forward to an exciting couple of days of discussions with everyone. Thank you.
Thanks so much, Evan. I'm Hayden Barnes. I'm the open source community manager here at Determined and the wider HPE AI at Scale team. Thank you so much for that keynote. We have a lot of great content lined up for today. Just so folks know, they will need to exit the main stage and look on the left-hand panel, and they will see sessions, and they will need to jump into those sessions. But again, thank you, Evan, and we really appreciate you. We have our next session starting in just a couple minutes. Thanks everyone who is here. And we're excited to be streaming to all of the platforms that we're streaming to. Let's see. Do we have any initial questions from the community before we get started with our next session? If not, we will close the main stage and hopefully see you over in our first session in just a couple minutes. Again, thank you so much. We're excited to have you here and be streaming to all of these live platforms. And again, if there's anything you have to miss, you can check us out. These later on YouTube. We'll produce those for you and make them available over the next week or so. So thank you again. Welcome to ML at Scale, and we will see you in our first session. Welcome back to our first session. Thank you for joining us this morning. We are joined today by Aurélien and Christian to talk about building enterprise MLOps solutions at scale. We're going to be starting off with some experience and tools leveraged by HP Enterprise. And we are excited to share these with you. These are the open source technologies, including Determined and Pachyderm and other open source tooling. And we're excited to share them with you. So with that, I will pass it off to our presenters and let them take it from there.
Thank you, Eden. Hello, everybody. Let me show you the agenda. So thank you for being with us today. I'm Aurélien, and with Christian, we are part of HP pre-sales, HP services, sorry for this. And we are working, we are dedicated to we are a worldwide part of a worldwide team, and we are dedicated to AI projects. So it can be machine learning, deep learning, MLOps, data science. And we are collaborating and supporting our HP colleagues from different organizations, high-performance computing, pre-sales, or delivery teams in the different countries around the world. Okay. As well, we are working as well with partners on the different projects. So as you may know, we have in HP, we have many different assets. So it means lots of flexibility and for the engagements. And today, what we will do is to go through a discussion and a view about a high-level view about engagements, the components, platform components, and the services around this. So you will see it's really an open framework. We won't go into the technical details or the sales perspective, but the idea is really to position the life cycle and the component. Don't hesitate in the chat if you have any questions. We will see if we take them live or at the end of the questions at the end of the session. So this is really, don't hesitate to interact. Okay. If you have a look on the agenda, we will start by the enterprise use of machine learning. It will be quick, but the idea is to position our topic of today about AI opportunities. Then the services and the engagement models. So this is where we will see the main three types of services and our engagement model, which is pretty incremental, iterative, and a very concrete approach. You will see. Then it's a topic that is really hype at the moment. LLM, the large language models. So it's hype, but it's really interesting in our case around MLD, and we have a good partnership in HP. So it's interesting to say a few words about this, what we are currently doing around the LLM. Where to start? It's highly pragmatic. The sales, well, the engagement life cycle, and to position how we manage the different phases and how we collaborate with our partners and customers during the engagement, and the main component, the platform and the services, the scope of an engagement. So for you to have a view about all of this. Then MLOps challenges. Christian will explain you the different phases of MLOps and the component, the challenges, and then the customer use case explained by Christian. Without checking the Q&A, let's start. Enterprise use of machine learning. So as you can see here, there is no point to share some market analysis or whatever, but in a few words, it is said everywhere that AI experts are here to provide solutions to unlock business values. Actually, it's not a matter of playing with data, it's a matter of collaboration. So this is really what is an AI, data-centric AI opportunity. It means that we have different stakeholders that are expressing their needs. First, there is the people owning the corporate data. Can be obvious like this, we need data, but it means the knowledge of the data inventory, the access to it, the ethics, the data protection, the data lineage, the data models. So when we are characterizing this kind of opportunity, we really need somebody with this kind of knowledge in depth and the accesses to this. Depending on the customer, can be really large around the world, for example. Industry needs, it means the business requirement, the industry knowledge of the industry, of the specific opportunity. Depending on the customer, it's not so easy. Okay, and this is where, and we'll talk about this a bit later, but we can leverage some partners as well for some specific industry use cases regarding the IoT, particularly analytics and IoT. And ML expertise after this is not only the data science, but all the related experience, expertise, the advisory, the architecture, the component, what we will see today. So enterprise use of machine learning, we are dealing with use cases where we need a high level of collaborations between different stakeholders and team, but I don't have the same priorities, don't have the same responsibilities and skills. So this is one of the challenges and one of the interests as well. Next one, we are here on the different services model. I'm monitoring the questions and chat, seems okay so far. So here you can see the three ways that we can engage in terms of model of services. The first one on the left, HP develops and deploys your AI model end-to-end. It means that it's all inclusive. So we have some customers, and where we can start really early phase to talk with them and to share around their data journey. And we start with advisory, and we can provide really the journey on several quarters, years, with the qualification at the beginning, some POV, the platform, and this is really something that is driven end-to-end by HP. This is possible. We have all the different services and technological stack. In the middle, you can see the custom approach. So here, just imagine that we can have some customers, they have their own data scientists, they are building their own model, and here they need only some component, specific component. So, for example, to optimize a specific algorithm, to have a specific platform, and this is where here we can engage more with a more detailed scope. We have several projects where we have the mission. We have a mission between the IT department and the data scientists from the different business organizations, and we are helping them to follow the project, the POV, and we are between the organization of the same inside the same company. So just for you to give you an example, so you can imagine that we are really tailoring our proposal. And then the last one that you can see in terms of service models, we can onboard some, we can put some AI delivered by a partner software inside one of our edge, for example, inside of one of our systems. So in this case, we are providing the gears, the service potentially, but it is embedded. We have different IoT bundles around this. Think about video analytics, for example. We will have some partners delivering the capability to analyze the video streams, and everything will be embedded, and we can prime on an opportunity around this. Okay, so this is the high-level view of the service models. Here you can see our engagement models. Seems a bit simple like this. The idea is to have an iterative and structured motions when we are dealing with the opportunities and the project, and to have an incremental approach. So we are starting by the explore phase, and this is where we are aligning the team, the needs, And this is exactly what we were talking just before about the different stakeholders in order to scope correctly and to make sure that since the beginning we have the right people onboarded inside an engagement. Inside the customers, inside the same customer for a company, we need the different stakeholders, the partners, and as well for the different HPE teams. Okay, so this is really what we are doing. This to give you an example, during this phase, we are positioning advisory workshops. And after an AI advisory workshop, at the end of this explore phase, you will have a list of use cases categorized and with priorities. So it will be the outcome of the explore phase. Then, if we go to the experiment phase with our list of use cases, we will be able to go more into detail, to ask more data sources inventory, maybe to extract some data set with the customer and to put in place a POV, a proof of value at this moment. And here, we will have the list of use cases, and we will put in place a platform. Can be at different. We have different solutions to do this, different possibilities, and we will test the first use case. We have methodologies in order to design new AI use cases, machine learning or deep learning tools as well. And the spirit here is to say, okay, if we have to fail, we fail fast, and we go to the second use case on the list. This way, during this experiment phase, we are progressing because it has been scoped correctly at the beginning. At the end of this experiment phase, this is where we will see with the customers and the partner how to evolve and scale to put all the services and the platform that we have tested during the POV phase into the production to be operational. Yeah, I will provide more details just after. And this is as well during the evolve phase, not only technically, but to speak about the pricing model of the different components. Okay. Can be and the way to operate them. So it can be a really different kinds of approach for the last part. And then just imagine that we have started with one successful use case. We will restart with another ones or another category of use case in our list, and we can restart the cycle. Of course, not from scratch, but that's the idea here. A few words on LLM. It's very generative AI and large language models. It's very hype, but it's quite interesting in terms of use cases for us. And we have a good partnership in HPE, and MLDE Determined AI is used for this with Aleph Alpha and for this kind of use cases. What you can see on the slide here on the left, you can see here. So first in the middle, you have the different use cases. So you can start with only helping a customer with the inference, doing some prompt engineering around the large language models and the usage of the large language model, the interface, optimizing the model, advanced optimization techniques, fine-tuning, and retraining the model. So, and here you have the scale of the hardware resources that can be needed for this kind of tasks. Okay, so pretty small, low at the beginning, and very high if you have to retrain completely LLM model. Just have a look for ChatGPT-3, some KPI below. And of course, at the same time, you need some skill sets that are highly specialized when you are on this kind of use case. So this is really to give you an overview of the different services and opportunities that we can have around LLM. If you have a quick look on the KPI, you can touch that it's really in terms. You can imagine beyond the data science, the experience needed in terms of management and what kind of what is at stake with all these kind of use cases. in less than 1 minute, you can see here for LLM exactly the mapping of our explore, experiment, evolve approach. And you see the different kinds of services around LLM that we are positioning. Advisory for explore, we have our advisory workshop that are prepared for specific LLM use case. Experiment, we are ready to work on the different kind of services, the prompt engineering, and this and the same thing for the model optimization. POV, MVP is minimum viable platform. So this is all these kind of things that can be addressed during the experiment phase. And evolve, moving at scale. So here we are. This is what we have for the LLM part. On this slide, here, this is high-level view of the engagement model. Okay, it's not so complex. The idea is it's really open as well, and you can see that we have 3 main phases. There is a first phase around the awareness, the pre-sales. If you want with a demonstration here, then still a proof of concept, proof of value. And then the deployment into production. We are still following this engagement life cycle with the explore, experiment, evolve. Okay, this is still the same methodology. We want to avoid, when we are doing this, the big bang approach, which means we are talking during months about a big platform, and at the end, after months, it's deployed, and there is lots of things that we have to discover and to modify. So this is really something that is a methodology that is built to avoid this kind of pitfall, and it is really use case oriented. So when we are dealing with a Determine AI and Pachyderm, when we have a PDK approach here, during the first phase, we will do some awareness, can come from the account team that are in touch with the customer. Same thing, we can have partners reaching us to be part of a consortium. And this is all that we are doing during this first phase. This kind of discovery and discussion, potentially advisory, if it is needed, we can position some strong advisory workshops. And here, at this moment, we'd like to do, when it is about Determine AI, a demonstration. It's not a video that you show on the screen. It's really a custom demonstration with MLD experts on our side around Determine AI and the different kinds of approaches that are possible. But to have a detailed demonstration with between data scientists, really to touch intel and to ask questions. Then during the second step, the proof of value, when it is about the PDK approach, it can be we can have very, very light proof of value in the middle, or more proof of concept dealing with the platform. It's scope-based generally, because it's highly flexible here. Let me give you some example. We can have a quick proof of value on data. We extract some data sets from the customer, of course, with the customer approval. And we play a proof of value on our premises in HPE. So it's quick for the customer, no impact on their data center or whatever, and we can validate the relevance of the data pretty quickly. But this is something that we can be on the other side. We can have done lots of qualification during the advisory, and at this moment, what we need is more a proof of concept on performance. We have qualified the model, what we have to do, and we will need to gather a piece of, or to get connected to some data sources to test, to have a first idea about a quick bench to understand what we want to put into production. This is another kind of proof of concept. Same thing, we can have proof of concept around integration of specific engine, proof of value to optimize existing model. So here, this is really custom, and the purpose is really to do the risk management, the risk mitigation on the project. And this is really open, actually. This is where we are testing different projects, different approach. And the objective is to be ready for the deployment into production. When we are into a production, when we are moving to production, we know the component that we will be needed, we know the size, the scale, the integrations, the challenges, the teams and the expertise. And during the last phase, we can as well discuss about, of course, some integration, and technical things, but as well to adapt the services based on the POV outcomes. Some services can be delivered by HPE as well into production. Some other services will be delivered by somebody else. We can train people, we can do knowledge transfer during POV. It's the opportunity for a customer, for example, to train a team of data scientists. So this is exactly what we are doing at this moment. And this can be discussed at this moment. And then we can adapt as well the pricing model, depending on what we want to choose. We can have done some tests, proof of value, on open source versions. We want to move to an enterprise version, or the opposite, for any reason. And and we can change as well the way to the pricing model. We can move some part of the platform to as a service approach, for instance. All these kind of things are discussed before during this proof of concept POV phase. It's an open life cycle, as you can see. Okay, so we discuss the engagement, we test what we have to test in the middle, and then we can propose in collaboration the right solution. Last view before handing over to Christian. Here you have a view of the services that can be attached around the data platform based on PDK, Pachyderm, Determinary, K-Serve, or Seldon. This is the baseline that we are using, but it's flexible. It can be open to other components, of course. Have a look on the layers. Of course, we have the hardware, the servers, the GPU. We have the storage as well. It can be custom, specific, depending on the use cases. So this is a specific point. What we don't see here, but think about this, we can have some additional tasks around schedulers and orchestrators. Depending on what is existing in the customer premises, it can be some integration at this point can be needed. And then we have the data engine in charge of the MLOps pipeline. Okay, at this layer. All around, and in blue we have the data flow. This is the what is represented on the slide, and all around you have the different services that touch a specific part. So you have, of course, the services related to the infrastructure in itself, then more globally the data platform. And this is where, at this moment, between the platform and the data science services, that you will find the MLOps services. Christian will give you more details about this one. And this kind of MLOps services are here to allow the next ones, the data science building of the use cases. Okay. So this is how we are shaping the different activities and components around a data platform. Still, proof of value possible, proof of concept possible in every direction, depending on what we have to put in place together. With that, I will hand over to you, Christian. I don't see any questions.
Thank you, Aurélien, and hi all. If you can move to the next slide, please. Okay, so let's go more in the MLOps topic. As mentioned by Aurélien, we see application of AI everywhere around us, but most of organizations struggle to make AI projects successful. And if we look, for example, at surveys by IDC and similar companies, they all agree that most AI initiatives fail to go to production. So for sure, MLOps is the solution and helps organization to reduce operational costs and to be responsive in the decision-making process, for example. However, there are many things that can go wrong when moving from the experimental phase to the production phase. And we can see them on the next slide, please. So here are some common challenges we observe among our customers, both technical and operational. In the technical ones, we see, for example, lack of skills, which is related to MLOps best practices or knowledge of technologies and products or in software integration, for example. Lack of automation is because of lack of tools or experience or knowledge. A typical case here is when data scientists need to ask different people to provision what they need because they are not expert or even interested in IT tasks. And in addition, during the deployment, each step may be manual, so exposed to human errors, which is a big issue. And complexity, MLOps landscape evolves fast. It is difficult to keep pace with all these tools, but most of all, data scientists want simple tools that just do the job. Again, they do not like to waste time to solve IT problems like integration of software components, software configuration, and so on. Now, in the operational column, one problem is cloud economics. To scale solutions in production, you have to manage expensive cloud services, including monitoring of them. There are also management issues related to complex environments, for example, dealing with edge nodes, or to maintain and monitor multiple models at the same time. As well, for the same reason, it is difficult to build functioning MLOps pipeline from scratch because it is difficult to proper deploy MLOps tools and integrate them in the target environment, and also to maintain it and keep it up to date with the latest versions. So if you go to the next slide, please. So when we look into the MLOps life cycle, we can represent the main MLOps stages connected together in a loop, because MLOps model are kind of living entities that need our constant care. They may need to be adjusted from time to time when external condition changes. For example, there might be a degradation of model performances. Think of changes in the distribution of the input data, for example. But each step of the MLOps lifecycle has challenges. The very first one is probably the most important because it's related to the definition of the business goals and the expected results. And for example, as HP, we can help here with a workshop with customers. We will see it in a moment. Also, ethical concerns may emerge here. And the next step, how to access data. This can be a big challenge. You may have unavailability of data. You may need to combine data from multiple sources or privacy issues for sensitive data, or dealing with volume, variety, velocity of data during the ingestion. But this is just some examples. Model development, we all know that data preparation is the most time-consuming task. There is a lot to do, data cleaning, conversion, normalization, and so on. And each of these may be tricky. Think, for example, of how to deal with missing data or with noisy data. And also, feature engineering might be tough as well. Another problem is lack of collaboration tools or bad usage of tools. It may be source code that is not versioned or not up to date. So this means in the end, information not shared properly among teams, different teams. And this in the end gives wrong information. In the model training, we have different issues, mostly technical issues like spinning up compute clusters efficiently. It is not easy to set up a distributed training environment. You need scalable resources, you need the GPUs, or you need to support the different AI frameworks and tools. And to make the most of computer resources, you need to schedule and parallelize your workloads properly, especially if you wanted to reduce the training time. Think to HPO, for example. And this is tricky without the proper tools and the experience in the field. Integration, also for integration of software components for production is not simple. It must be well planned and structured. For example, not only code versioning is mandatory in MLOps, ML models must be versioned as well, and sometimes data sources as well, data sets, especially if you care about data provenance and model explainability. Model packaging and deployment must be done using CI/CD and continuous training methods to avoid any manual process, which again are error prone. The deployment typically is slow because it requires the collaboration of different teams like ML engineers and IT operation. And in addition, the deployment requires proper scalability. And often you have portability issues. Also, you may have security threats. Think of using web services for inference, for example. And last but not least, monitoring. So here the challenge is to detect model drifts or any anomalies in real time, and to react quickly when updating the model in production. So this means to have systems that automatically detect data drifts. So to address all these challenges, it is important to have a well-defined process and to use the right tools the right way. And not only, also we have to make all the people collaborate in a controlled environment with the discipline. This is not simple at all because the entire MLOps life cycle normally involves the coordination of teams belonging to separate departments in the organization. We have IT, data scientist teams, and so on. So the goal here is to bring governance in the process, to introduce automation as much as possible to guarantee reproducibility and efficiency. So in the next slide, please, we see what we have as HPE services. So we offer a number of services to help our customers to address the challenges we have been talking about. And in these slides, there are 3 examples of services in the MLOps space. So the first one I want to mention is the ML Development Workshop. This is an interactive one-day session with customer. And here we discuss business priorities and challenges with the right stakeholders. We want to identify what is required in terms of components and functionalities to address this kind of requirements. The discussion includes the exploration of ML use cases. In the end, we elaborate a transformation journey from manual or semi-manual ML to ML at scale, so to fit production requirements. And there is a discovery phase to assess the existing situation and understand what is the to-be situation, so where the customer want to go. The output of all the workshop is a roadmap detailing all the steps to be taken to achieve the to-be. And the second one is the proof of value service. So generally speaking, POV services are really scope-based and have different flavors. POV for MLOps is a custom service that is oriented to specific aspects of MLOps. It may be a feature engineering or model training or model inference or more. It is a service based on a custom statement of work and is focused to build an MVP that typically is completed in 2 or 3 months. and the implementation can be done at customer side or in our HP labs. And the third example is for customers that are more mature in their MLOps capabilities, and we have different services, MLOps focused or model focused. For example, the model migration is about porting existing models into environments that allow them to scale in production, and typically we use Determined AI for that. This service is made of 3 phases, one for assessment and preparation of data and models, the second one for the model migration itself, and the final one for the documentation and best practices. Instead, the ML models design and build is more model-centric, so it starts with the identification of the target use cases, the expectation, then we have the definition of the architecture, a proof of value where we build the ML models and we evaluate the performances, and finally we put to production. So now to give an example, if you move to the next slide, Aurélien, please. So we work with customer to solve MLOps challenges in many contexts and for different levels of maturity. So some customers are at an early stage, like they are able to build an ML model, but they are far to make it usable in a production environment. Some other customers have a MLOps process already in place. They are very knowledgeable and experienced in the field, but they are looking for innovative ways to improve some aspects of specific MLOps steps. And in this example, we have a customer at a high level of maturity. It is a leading retail bank in Europe with a large team of data scientists who work in financial use cases like fraud detection and prevention. And before engaging with us, they had already designed a full MLOps pipeline, and this runs on a hybrid infrastructure. Some workload running on premise and some other on cloud, especially for workload peaks. So what was the need here? The data science teams runs and maintains many models. They have like more than 20 use cases, and the interest was in the optimization of the training piece, which makes sense, especially when it comes to run training workloads on the cloud. You know, big size instances with GPU are very expensive, and so they were looking for optimizing the usage of whatever computer resources, and so to be more cost effective. So Determined AI was a natural fit, of course, and some core features are very appealing in contexts like this. First of all, Determined AI cuts down the training time because of an optimal management of distributed training, especially data parallelization. To distribute the training workloads across GPU or CPU resources. This is one of the aspects where Determined AI shines. And in this context, automatic HPO is another element that helps the training process to be time effective. Another important element is automation of allocation of GPUs with several scheduling policies. And overall, a user-friendly interface that made easier the management of the ML models. Of course, each of these factors brings to cost saving in the end, whether you are using cloud or on-premise resources. Next slide, please. So some more information in terms of infrastructure. The customer have a dedicated AI cluster, and all the software architecture is cloud ready. They run all the software components in Kubernetes, even in the cloud. The MLOps flow is made of open source pieces and some bespoke components. The process of model build is very controlled, and for example, data scientists develop their models according to a well-defined template, and this simplifies the industrialization of ML models and makes them ready for production faster. An important point here was security. In general, customers in industries like this are very concerned about all the security aspects from user authentication, authorization, data protection. And okay, overall, for the adoption of determined AI took some steps. So in terms of services, after the presentation of the product, we decided to adopt POC approach, the one mentioned by Aurélien. So first on the cloud, to allow the customer to explore and test the product functionalities by themselves, and then we deployed the POC into Kubernetes on-premise. As next step, as HP, we're going to support customer in the model design and build, especially for an optimal product usage. This is a typical case where data scientists want to focus on the use case and not much in product details or IT-related issues. And the determined AI is going to be used to address new use cases to build and train related models. And then the idea is to migrate the remaining models. With that, I will go to the last slide. Hope we have some time for Q&A. And please, can you go to the last slide, Aurélien?
It should be on its way, Christian.
Okay. Okay. So as global data and AI practice, we have been present in many relevant events you see here, and also you can get in touch with us and meet the HP teams during this kind of events as well. And in the links here, you find more information about our services and solution. With that, I hope that we gave you some indications on how we approach enterprise MLOps in HP services. And thank you all. We are open to questions.
Then we have one question come in.
I cannot hear you.
You have the question in the chat if you want, Christian. How did this financial institution find Determine, and which other tools did they evaluate? Sorry, Hélène. Just saving the question.
Yes, thank you. So it was during a discussion with customer. It was a general discussion about MLOps, and we presented some tools that could be useful in their context, and one of these was Determined AI. And immediately the interest from the customer was there, and starting from that point, we started other conversations and try to deepen all the functionalities of the products.
Thanks, Christian. Can you hear me now?
Yes.
Awesome. We had one more question come in from Kieran. Is the MLOps lifecycle here managed by HPE Ezmeral or any other solution?
No. It is any other bespoke solution. If you are referring to the bank example, it is a bespoke solution.
Fantastic. And do you have any thoughts on the benefits of having an open source solution here implemented in these environments? Like, do you see customers engaging more because of this open source? Does it lend to modularity?
Yeah, well, this customer usually works with open source solution. They are very knowledgeable, not only in the ML space, but also in the software development. So they have a very strong knowledge about software development, DevOps, MLOps. And so they are not shy in exploring new tools that could be beneficial for their use cases. So when we mentioned that Determined AI was open source, started as an open source product, they were very interested on that, and also they started exploring by themselves all the documentation of the product, and also tried to do some tests by themselves, which is cool.
Fantastic. Yeah. Having that open source tooling available allows anyone to kind of experiment and get started and spike, whether
Exactly.
they're community members, small startups, or big enterprise like banking. We do have to move on to the next session. The next session is a really interesting session from a community member at Booking.com. Who is showing LLM model ops at scale. We really appreciate everyone's attendance here. We're going to go check the sessions button on the left-hand corner that says sessions now, and look for large language model ops. Christian and Aurelian, if you want to sit tight here, there are a couple more questions and you can answer them here in this session. But everyone else, if you're done, let's head over to the Booking.com session. Thank you so much.
Thank
Thank
you.
you.
Have a good event, guys. So we will see if we have specific questions. So this session is closing, and you have to jump to the next one about large language models. So one of the use cases to have. I don't see additional questions at the moment in the Q&A. Let me check. So I don't think so.
Is there any solution for reference architecture available for reference? No, we don't have a solution reference architecture in this context. If you are referring to the customer example, or maybe the question is related to our services.
Oh, no, I haven't seen it. Okay, sorry for this. Where there are challenges and expected costs when going from POV in cloud. Okay, so which one do you want to answer, Christian? You were taking the. Is there any solution reference architecture available for reference? Yeah, not particularly. And this is what you said, Christian.
Yes, if the question is related to the customer example, we didn't touch the architecture, the MLOps architecture that they have here. So we were very focused on determining the AI product.
Yeah. And in terms of reference architecture, what we are doing, because it's very data dependent and use case dependent. So we have some guidelines to do the sizing actually, but and this is what we are doing during our advisory workshops. But this is why we position POV.
New area. I'm no way a subject matter expert, but I have a thought process and I would like to run that thought process by you. Obviously, to attend conferences again, although we are not meeting in person, but it's still better to attend sessions, etc., and definitely discuss the data and ML ecosystem of a typical tech organization. Next slide, please. Yeah, so before we dive deeper into it, let's clarify the terminology. So there are a lot of words being thrown around, and I think these words enough are causing a lot of confusion. So what is AI, what is ML, and what is deep learning? And when we get into the operations part, what is FMOps or what is LLMOps, right? So let's start from the superset, artificial intelligence. Artificial intelligence is basically something that can reason and infer like a human does, right? If I give you a data set that if you can actually come up with a statement or a action that is not stated in that data set, you are inferring. If you can infer based on the data set, you are artificially intelligent, right? Machine learning is basically a subset of AI. Use use cases. If A, then B, if B, then C, then you can find out if A, then C, right? So it's not that difficult. Machine learning is a subset, and deep learning was always a subset of machine learning, basically neural networks, etc., and what we all studied in our colleges, etc. What has actually changed in the advent of the industry is compute has become much cheaper. So the things that we thought theoretically possible when we were doing our undergrads and postgrads is now possible. That's what we are here discussing, right? Let's dive deeper into some of the other terms that I use. MLOps is basically machine learning operations, right? Uh, Anything becomes complicated enough, developers like to add an ops layer on top of it. So development became complicated enough, Git came into the ecosystem, etc., etc. There came a layer called DevOps. Security became complicated enough, SecOps. And now ML has become complicated enough, you have MLOps, machine learning operations, anything that abstracts the operational part, the productionizing part from the application part. And now data has become big enough, so there's a data ops concept as well. Now, MLOps is getting deeper and deeper into large language model ecosystem, and new terms are coming out. So terms like FMOps, which is foundational model ops, and LLM ops, large language model ops. And what is the difference between them? Basically, foundational model ops is anything that is related to do with a foundational model. You know what a foundational model is. I'm sure you have heard of it. There are a ton of foundational models. LLM ops is a subset of FMOps because LLM ops are only large language models, but a foundational model can be an image model. It can be, let's say, stability.ai kind of a model, which is doing graphical inferencing or sound-based, something that Facebook releases recently, AudioCraft, etc., etc. So FMOps is a superset and LLM ops is a subset. Next slide, please. Now let's dive into a typical model ops flow. And your typical ML ops flow has two components, right? It has the model training component, it has the model serving component, right? In a typical tech org, so ignore the names because it is within your ecosystem who are doing machine learning, right? When you're training the model, these departments, these ML practitioners, what they do is they give a training request to the ML ops layer, which is the abstracted productionizing layer, and there's a feedback loop in the middle. And the ML ops layer is actually giving a call to the data ecosystem. Your data ecosystem is your data lake or a data mesh, depending on how complicated and how evolved your ecosystem is. And what are the typical ecosystems in the MLOps lake? You have a typical model training, model serving, you have a feature engineering component. A lot of rules and regulations are coming up in the MLOps ecosystem. So there's the ML governance component. Obviously, because it's a tech system, you want an observability layer. So there's a ton of advent into ML observability, and you have an experimentation layer. There's a tie into the feedback loop, which is gaining a lot of traction because this is how you actually control the components of a model, etc., in real time, or let's say non-offline or online mode. Right? This is what a typical training loop looks like. Next slide, please. And once you have trained the model, you actually want to serve the model in production. And the serve the model production looks like this. You have your end consumer interacting with your app, be it on web or mobile. The same applicative ecosystem that you have in your organization is actually deploying your machine learning model as part of an application. And what is happening is that model is putting a deployment request to your MLOps layer. So your model serving ecosystem comes into play herein. It's not so much interacting with your data ecosystem. There are exceptions, and there's not a lot of feedback loop interaction. This is what a typical MLOps serving ecosystem looks like. Now, what we will do is we will dive deeper into how LLM ops, how large languages or foundational models have changed this ecosystem. So let's go next. Now, with LLMs, something has definitely changed. What has changed is in your model training ecosystem, now your applicative layer is calling the model. But there are various ways to call a large language model, right? Not every organization is actually training a model in-house. So there are three typical ways that at least I see where LLMs can be involved into our ecosystem. A, there are a lot of enterprise APIs like Bedrock, like OpenAI Foundry, NVIDIA AI Foundations, where you can just give an enterprise call to a publicly available large language model. And how you can do that? You can do it with a wrapper or a middleware kind of a approach. And in this ecosystem, what you would like to do is you would like to optimize on the prompts. And this is where the new concept of prompt engineering has come into the picture. This is one way you can actually train and serve the model. The second way where actually you can interact with a large language model is you can give the model a certain amount of memory, right? So this publicly available model, although it's very smart, it's dumb also. It's not deterministic in a way, right? And it's definitely not trained on your own local context. So a lot of people, what they do is they deploy a vector DB in a closed loop with nearest neighbor search so that you can give localized context to your ecosystem. That's why the embedding management layer comes in the picture, right? And definitely, if you're looking to deploy your own models, you're looking to fine tune your own models. What fine tuning means is you download a model, let's say model as a service, and you actually change the weight of the model. And that is actually you train it on your own data so that the weights, the individual million parameters that you have, you can change them to retrofit into your own particular needs. And depending on those three use cases, there is additional layer that comes to both your model training side and next slide, please, and your model serving side, right? And what we're going to do is, and we will go into details, we will look at the product iterations. Next slide, please. Yeah. So as we discuss, what we are going to do is we will get into a discussion about each layer, what each layer does. We will discuss the complexity of each layer before and after large models, and we will discuss opportunity from a product point of view. What has changed? Where are the gaps from a product point of view? And obviously, there's the advent of a lot of SaaS startups. As I think there's a very famous saying, when people go gold hunting, sell shovels. There's a lot of shovel makers also in the industry, a lot of SaaS tool providers who are actually looking to evangelize and get into these niche areas where value is to be found. Next slide, please. So let's pick the first one, the data ops layer, right? A bedrock of any ML system. All of us presume that, okay, data is well labeled, data is well tracked. So no ML ecosystem is worth its salt if there is not well lineage, properly labeled data. And this is where this data ecosystem, although it's a very small component, it's I think one of the most critical component, right? Well robust, well lineage data is a prerequisite. This layer has many nuances. As I think a lot of you might have heard of terms of data lakes, data fabric, data mesh. A lot of VC investments has already targeted this area. It's a very mature area, but it keeps on springing up hot area. But with non-LLMs, typically a lot of data lakes in the ecosystem relied on structured data. Your data was either in a protobuf format or Avro format. But now you are starting going to think about non-structured data, because your large language models would be typically text and images directly interacting with the front end, right? So this has changed. What changes with LLM is, with an LLM ecosystem, data interaction is no longer limited to structured data, but extends to unstructured and semi-structured data. And this is where, if you are a data practitioner, this is a new advent for you. Because although you were storing unstructured and semi-structured data, I don't know how much you were actually using it for training into your ML ecosystem. Maybe you'll have to rely on that. So this is something that has changed, at least from a data layer. Next slide, please. Now discuss the model building and the model training part, right? As we discussed, right? If you are just typically doing model training on your vanilla MLOps ecosystem, you typically iterate upon multiple model deployments method. You're either training on light GBM, TensorFlow, etc., and this is how you bring value to the business, right? This layer is your first interaction with the data ecosystem. A lot of formats keep on coming: linear models, non-linear models, right? A lot of VC investment has already gone here. In a typical non-LLM world, model training is a middleware. You're just a layer between data and, let's say, the model production pipeline. Right? What has changed with LLM is, as we already discussed, now there are multiple advents of actually calling a model. You can actually call a model as an enterprise API. So model training is no longer limited to, let's say, a typical model builder format, but it can actually evangelize into a typical middleware API, right? A wrapper middleware edition could be envisaged, and this is what the industry is going into. Next slide, please. What changes from a serving layer point of view, right? Again, serving is where production line of the platform, right? Multimodal serving. So if you are a typical big tech organization, you are serving hundreds and maybe thousands of models, etc., etc. Highly extensible model. This is your workhorse, right? Highly extensible requires scaling engineering and scaling number of models. A lot of VC investment and optimization has gone into software and hardware side of the business. All of us know GPUs, etc., etc. In a non-typical NNM world, I don't know how typically complex models you work on, but typically one GPU has been more than enough, right? What has changed with LLMs is, for LLMs, a singular GPU is not enough. So you'll have to start thinking about distributed GPU training, right? Additionally, I don't know whether you're following the industry or not, but a lot of tech organizations are trying to think beyond GPUs. GPU was a happenstance, right? It was a graphical processing unit. It was made for gaming. And happenstance, we got to know, okay, it's very good for, let's say, uh, data-intensive tasks, right? But a lot of industry leaders are coming up with their own specialized hardware, Trainium, Inferentium, as AWS, XPUs, etc., etc. So there's a certain amount of industry investments going on from a model serving layer as well. Next slide, please. We come to the feature engineering part. What is typically feature engineering? I like to call feature engineering as feature computation plus feature store. So feature store is a very natural transition for a lot of machine learning practitioners. It's basically a marketplace where you can have ready-made online and offline features ready to deploy in a Lego kind of a format, right? In a typical MLOps ecosystem, this has been a very hot area, right? A lot of feature stored industry leaders are already there. I don't know whether you know about Tekton. It used to be part of Uber Michelangelo. SageMaker has a feature store. A lot of VC investments has already gone into it. In a typical non-LLM world, most of the use cases used to be scalar, right? Although there is value proposition for vector use cases as well, embeddings have always been very important for a lot of use cases, but I think most of our use cases used to be scalar based. What has changed with LLM, as we discussed, providing a memory loop to a public enterprise API is also possible. So whilst online and offline feature serving was always important, maybe vector store and prompt store. So this is a very new area that I've at least been trying to read up a lot on, because if you have, let's say, a LLM into your loop of your customer interaction, you typically have a lot of latencies. A lot of people are realizing that a lot of optimizations that we used to bring in a typical chat use case can heavily be used in the LLM ecosystem as well. So prompt caching, prompt storing, etc., is also a lot of people are evangelizing on, and this is a good area. It's a very, very good use case, at least from a feature engineering point of view. Next slide, please. We come to the ML governance part. If you are part of Europe, or let's say part of Europe, governance is part and parcel of your ecosystem. Regulatory, especially for data and ML ecosystem, Europe is on the forefront of path-defining regulations. The typical MLOps ecosystem needs to build tooling to adhere to these tools, to these regulations, and a lot of solution providers have come forth. Help you be EU AI Act compliant, etc., etc. What has changed with LLM is, I think with LLMs, the scrutiny over machine learning is only going to increase. This is not going back. We are not going to be, let's say, in the ecosystem where ML is left open and uncharted. So a lot of investment that you typically associate with your system mesh are something that you have to do in the ML mesh as well. So you have to think about model versioning, model data versioning, etc., etc. So there is a certain amount of investment going into this area as well. Next slide, please. And then we come to ML observability layer. So ML observability has been a new thing, but it has been around for a very long time, right? If you have known vendors such as Arise, Aporia, Labs, etc., etc., your system observability only goes so far. Let's say if you're getting into the data and ML observability part, and this layer has been always very important because we want to have a, let's say, 30,000 feet view and maybe even a closer view of your machine learning and data ecosystem. But with the advent of LLMs, this layer has become all the more important because we know LLMs are prone to hallucinations, right? And a lot of output moderation, how to do content moderation, how to make sure that we are guardrailing the output of the machine learning model, the LLM model, is more than more important. So I think this layer has gained renewed significance again. Next slide, please. And we come to the experimentation layer, right? Any product org, any tech org is only as good as the experiments they run, right? Because if you're interacting, if you're in a product-based role or if you're in a customer-facing role, if you're not iterating and scaling your experiments, if you're not trying to find that secret sauce that makes your product addictive, you're not doing justice to the customer, right? With ML experimentation has always been a thing. There have been multiple ways to define ML experimentation. There's hypervariate experimentation, multivariate experimentation, etc., etc., and multi-hypothesis deployment as well. There are multiple tools in the industry, so this has been a very good area. Now, again, as we are discussing now, LLMs are coming to the picture. Maybe multi-model deployment can be an experimentation layer. Obviously, prompt experimentation is a big thing already in the industry. Next slide, please. And then we come to the feedback loop part. So feedback loop is a feedback collection mechanism. If you are working in a typical MLOps ecosystem, you use feedback mechanism for collecting a lot of data, maybe providing real-time or offline feedback to your model, so your model can be trained and changed according to the need of the customer. But with the advent of LLMs, this area has become very hot. This is red hot. Reinforcement learning with human feedback, reinforcement learning without human feedback. There's a lot of investment in this area as well. And I'm sure you have heard a lot about agents, etc. as well. So this is a very important area as well. I think a lot of investment from research point of view is also going into here. It is important from a product or a commercial organization point of view, but it's not breaking the bank. It's obviously very much more important in the AGI space. Next slide, please. And as we discussed, right, what are the three paradigms that we can typically use an LLM for? You can either just call a public API and optimize on the prompt, right? You can maybe call a public API and have a vector database as a memory, as a quasi memory, so that you're giving some context to the LLM. You are making sure that the LLM has a nearest neighbor search mechanism, so it's not talking hallucinatory, right? And finally, then also is fine tune. One very important thing to call out, they are not mutually exclusive. So I'm sure you can do prompt engineering with an embedding management solution. You can do embedding management with a fine-tuning solution. Fine-tuning is obviously the superset, right? And yep, as I said, you can mix and match, etc., etc. Next slide, please. And that's me. I hope you enjoyed the presentation. I droned on for around 20 minutes, but if you have any questions, etc., please feel free to reach out. I would be on the chat as well, but just in case I cannot answer you right now, I'm available on.
All right.
Yeah, that's awesome. Thank you, Sanchit. We had some good questions come up in the chat. We had some team members answer those. What major challenges did you face at training and model and deployment phases? Answer, it depends on the use case. Training is more and more a matter of GPU usage, optimization, and collaboration. In terms of inference, the speed of inference, the size of the model, the distribution of inference over different locations. Of course, we're seeing inferencing, on-prem, but also being deployed to the cloud, also increasingly inferencing at the edge, and all of those have very unique challenges. So one thing I wanted to mention is that coming up after the next talk, we will have 2 birds of a feather sessions. So we'll be able to actually break out into 2 groups, which will be much more interactive. You can come on cam, come on mic, and interact with us. One will be dedicated more to ML theory and things like model drift is one of the questions that came up. The other one is more dedicated to ML like infra and systems. I'll be moderating that one. Isha, our MLDA, will be moderating the other. We'll have experts from both fields on those. Isha and Kevin and Jimmy will be in the ML one. Myself, Bradley, one of our backend infra engineers, will be on the other, and we'll get into some more, interesting things there. And you'll be able to come off, like I said, come off cam, come off mic, and we'll just talk about things. So in a few minutes, we have a session coming up by Corey Staton, who's one of our engineers on Determined, who will be talking about LLM batch inferencing using open source Determined AI. Just like before, once we wrap here, we will jump over to that session by clicking sessions. There's a nice red now button on it right now showing that sessions are happening. And you can find that there. So let's take a look. Let's see what we've got in Q&A. Let's see, Lalit asked, how is CI/CD, CT/CD complicated or different for LLM ops as compared to ML ops? So we'll see if anyone from our team or Sanjeet's team can jump in on that. But again, I think that would be a great question for actually, I think, Jimmy in the ML talk. We'll be talking more about systems and Linux and GPUs and that kind of thing in the ML tech birds of a feather. So if that's what's interesting to you, go join that. If more of these ML topics and theory are interested, join that one. And if you're unable to, join both, you're interested in both, the good news is all of this is being recorded. The raw stream will be available on YouTube for the next few days. And then we're going to splice up all these sessions and make them available individually on YouTube. So I'll make sure we post the link to our YouTube channel there so you can go back and rewatch anything you might have missed. So with that, I think we're going to wrap this session up and go ahead and transition to the batch inferencing session with Corey. So we're going to close this one out, go over to sessions, click LLM batch inference with Determined, and we will see you over there. Thank you so much. Oh, hey, Corey, and welcome everyone filtering in from the last session. We're excited to talk to Corey, who's one of our engineers on Determined, about LLM batch inferencing using the open source Determined platform. One of the advantages of Determined is that it is fully open source. We publish Docker containers, DEBs, RPMs. If you're deploying on Kubernetes, we make Helm charts available, and it is super easy to get started. We've got a lot of great docs at docs.determined.ai to help you get started. We also have the Slack channel that we've mentioned a lot. There's a support channel there that's monitored by the open source community team, myself, Isha, Kevin, and also engineers like Corey and Ilya and other folks who gladly lend a hand. But with that in mind, I'm going to pass it off to Corey to present on batch inferencing on LLMs. Thank you so much for joining us, Corey.
Yeah, thanks for having me. And hi, everyone. So this session is going to be a lot of code. So if you don't want to look at code with me, you're not interested in that level of detail, then maybe go grab a quick lunch break. But I'm going to walk you through a lot of different areas around how you, if you haven't seen it before, how you do large language model inference at all using the transformers library from Hugging Face, and then specifically how you would do that stuff on our platform. And I'll show you some of the features of our platform that you might use to look at different variations of performing inference with large language models, do some like performance testing, use some advanced inference features from DeepSpeed or Hugging Face, and just like a bunch of tips and tricks about how to do that. These tips and tricks are not necessarily the tippiest in terms of like, you should definitely orchestrate everything you do in this way. There's a lot of different ways to accomplish things with our platforms, and we're constantly working on new features. So we have upcoming features related to batch inference or online LLM inference, on our roadmap. So those sorts of things are going to change over time. But I'll show you some of the cool features that we have today. All right, so I'm going to jump right in. First, I'm going to share my screen. And you're going to see a crazy zoom effect until I switch to the appropriate window. Can everybody see my screen? Hayden, can you see my screen?
Looks good.
Great.
Is there any ability to increase the font size
Let's give that a shot.
to something like maybe 20, 24?
Oh man, how do I increase my font size in Jupyter Notebook? There we go.
I didn't mean to put you on the spot.
No, that's all right. It's the same as in every other thing. Okay, let's give
There
that a
we go.
shot.
That's very readable. Thank you.
Excellent. Awesome. I'll need to do that again later because we're going to switch away from Jupyter Notebook. Cool. So let's do some inference. So instead of putting you through watching me type everything, I've pre-typed everything that we're going to have here, and I'm going to copy and paste, but I'll go through things as I paste them in. So first of all, I launched a notebook on Determined. You can go to the Determined UI and go to tasks, and you can hit launch Jupyter Lab right here to get a notebook. You can also do it from the command line. But once you're in, we've got this not launched notebook, and I've made a new Python notebook file. So I'm going to install transformers. That's obviously going to be pretty useful for us if we're going to use Hugging Face transformers to do our inference. And notebooks often take a little bit to warm up at the beginning, so we'll kind of move forward while we're waiting for that stuff. So one of the things that you're going to run into is that every time you launch a notebook or other task in Determined, it's running inside its own container. So the file system inside that container is local in time to the run length of that container, and it's going to disappear after that task ends. So if we want to keep things persistent, we're going to need to use a shared file system. If you use Google Cloud or AWS or similar, there are options in our deployment scripts to automatically create a shared file system for you. If you have some more sort of complicated on-prem solution, you might have to do some configuration, which I'm sure we'd be able to help you do. But we want to make sure that Hugging Face lands all the stuff it's going to download into that shared file system. Otherwise, we're going to have to re-download models every time we start a new task. So here's some code for that. I'm going to, am I not getting syntax highlighting here? Something seems off. Is it too big for syntax highlighting? Interesting. All right, well, we'll check it out in a second. So we can do that by setting these environment variables, transformers cache and HF modules cache. One of these is for download model weights, and the other is for the download model code. And Hugging Face hides this one pretty well. You have to actually go into the source code to find that they have a separate location where they store the code. And here it is. We're going to put those both in the same location, which is going to be this run determined work dir shared FS. And once you've got your cluster configured appropriately, this will just always be available in every task that you run. All right, it's really taking a long time to start up this time. Fun of presentation is things never go properly. So we have a few more imports. Let's import Torch in that Transformers module we just created. And we're going to start off using a very simple model. This GPT-2 from Hugging Face is a very small GPT-2 architecture model. Awesome. So then, pretty straightforward if you've ever used Hugging Face before, we're going to create a tokenizer that we're going to use to turn our text into actual tokens that we feed into our model. Tokens being numerical IDs associated with different like subparts or superparts of words inside of sentences. And then we're going to create our model itself, and we're going to put that on our GPU device. So when you launch a notebook, you have an option to request a certain number of slots for that notebook. Slots being the GPU notion in determined. And here I've requested 1 slot, so we've got a GPU available. Let me go ahead and try and restart this kernel. See if we get any further. Okay, awesome. Cool. And now I've got a tokenizer. I've got a model. So I just need to write my generation logic. So this is going to be a longer function here. So I'm really bothered by this thing not working. This is not a good look. Sorry, buddy, bear with me a second while I debug Jupyter Notebook nonsense. Is our terminal working all right? Let's check that.
Yeah, this is how you learn the most during demos. You live debugging.
Okay, our terminal is having some trouble too. So this notebook's having some trouble. We're not going to worry too much about that. We'll be out of this notebook environment in a little bit anyways. So apologies, everybody. I'm going to get us some syntax highlighting by, I'm just going to, oh, I can't drag. Now I can't drag my thing between screens. Okay, this is just looking like a great demo so far. So let's do this. Let's go to this window. Here we go. Awesome. So I'm just going to paste all that code in here. So now we have some nice syntax highlighting. So imagine we're in a notebook that wasn't bailing out on us. So now we need some generation logic. So how do I take a tokenizer model and do some generation? So the idea inside of this talk is going to be, we're going to be looking at how long it takes to do generation. So there's 2 components to the generation. There's the stuff that you use as your prompt, and there's the stuff that you generate afterwards. And when you generate that stuff afterwards, you have to do it in sequential fashion. So I might have a long prompt, consisting of 100 tokens, and I can run my model on all of those tokens in sort of a parallel fashion. But once I'm done with that part, I have to go token by token by token. So there's different timing characteristics to doing that initial versus later part. So we're going to just do the simplest possible initial part here. We're going to use a single token. This BOS stands for beginning of sentence as our input. And then we're going to tokenize this using our tokenizer. So this turns the text into token IDs. There's a lot of options here, padding. This is telling us to return PyTorch tensors. This just makes the model not return something that we would throw away anyways. And this keeps it from adding anything additional, like further beginning or end of sentence tokens there. So we're going to do that tokenization. That's going to give us a PyTorch tensor full of integers. And we're going to put that on our GPU as well. Then we're going to call this generate. we pass in the tokens like this. We might have, multiple things that we're running simultaneously, all of which consist of the same prompt. And we might get multiple generations out. And we're going to limit how many new tokens it gives us. So this is how you do the simplest greedy generation. Greedy being, let's take the highest probability token at each step along the way. There's a ton of options that Hugging Face offers for doing these generations, like beam search and top K and top P, temperatures, that sort of thing. But we'll keep it simple for now. And once we've got that generation, we can decode it back into text using this tokenizer.decode function. This skip special tokens option keeps that from printing out some of these beginning and end of sentence tokens. So without having this in here, you would see a like bracket, BOS, end bracket sort of thing going on, which is somewhat noisy to read. And then we could just print out results. So this is how you might do this in a notebook. I'm going to guess our notebook is still just not working. Yep, who knows what's going on here. Sorry about that. This is a new cluster I just spun up for this demo, so I had this working fine on a different cluster. Apologies. So let's go back to code and let's add something here. So that's how we do generation. Let's now measure how fast that generation is. Nope, that is the wrong thing to display. Here, okay, something's going wrong. Apologies, everybody. There we are. Sorry about that. Okay, so let's measure how fast this generation is. So I've got this class I made here called cumulative timer. Very simple. It's going to have a start and stop. And it's going to keep track of how much time passes between when you start it and when you stop it. So I won't belabor the details on that. But what we can do is just take our generate function. Let's actually call it. So let's make a quick change here to have this, instead of decoding the text, let's have it return how many tokens it generated. So I can just sum up the length of all those generations. And this will be the total length in terms of tokens. And one thing you have to be careful of with Hugging Face is the thing it gives you back actually contains your prompt as well. Our prompt was of length 1 here, so we're going to cut that out. Cool. And now I can, oops. I can instantiate my timer, start it up, and then I'm just going to call that generate function with a tokenizer, my model, and we'll use a batch size of 1. Stop the timer, and then we can print out how fast that went. And if our notebook were working, we could actually run this. And you can see a printout saying how many tokens per second this was, or sorry, how many total tokens this generated, and what was the throughput per second, like the number of tokens per second that we generated. Okay, awesome. Feel free to interrupt with questions, by the way. And Hayden, if you think there's good questions from the chat, feel free to pop in with that. I won't be able to see the chat screen, unfortunately, given all the code flying around.
Hey, Corey, there's one good one that this might be a good place to stop. Viatar says, can I change the tokenizer translation of words into tokens, or every model has its own tokenizer and it's static?
Every model is going to have its own tokenizer. So if we go back up here where we create this tokenizer, we passed in a model name. Some models might share tokenizers between them. Maybe you create a derivative model and it uses the same tokenizer as the base model. But in general, you shouldn't make that assumption. You should presume that each model has its own. Does that answer the question? Cool. All right. So let's get out of notebooks because notebooks aren't doing so hot for us right now. Let's go ahead and create an inference script. So I'm going to create this file, script.py. So what I'm going to do is I'm just going to take all that same logic that I just had, and I'm putting it into a Python file. And I'm going to be able to execute that on the determined cluster by running what we call an experiment. And to do that, I need to create a configuration file that describes that experiment. So I'm going to create this script.yaml file. And we're going to update these script, Python, and YAML files as we go along to add some new features. So when I create a YAML file, apologies if you've been using determined for a while and you've seen some of this stuff before, but let's go over it real quick. You need a name. You can select a workspace and project. If you leave these blank, you'll go into the uncategorized workspace. You describe what you're going to run. So if you've used our trial APIs before, this is a different format. This is just directly listing the commands that you want to run. And this is the format that you'll use when you use our core API, which is what we'll use in this session. Those environment variables I set earlier, I can move those out of having to do this hacky thing where I go into OS environ and set them. And instead, I can set them right here. I also specify how many GPUs I want. Myself, I always set max restarts to 0 when I'm developing because it takes longer to notice where the bugs are if you let your script run into the bug and then restart a couple times. So that's why this is here. And then we have this searcher section. We'll talk more about that later. For right now, this is just something that we're forced to list out. I think we have changes coming in the future that are going to make searcher a lot more intuitive and eliminate the need to use this all the time. Okay, so this searcher single just means we're running a single experiment. We're not performing a hyperparameter search. We'll talk more about hyperparameter search in a little bit. Awesome. So I write a config file. I copy over my script. And if I jump over to Safari, let's see, right here. I've pre-run all the things that I'm going to show you here so we don't have to wait for them to run. Some of these things will take a few minutes. This is that script, and we have these logs here that show us the results of running that script. So finally, we can see, okay, we generated 32 tokens. That's the max that we requested. And this GPT-2 model was able to get 129 tokens per second. So great. All right, so let's go back to our script. And the next thing I want to do is incorporate a few more of Determined's features to make this a little nicer. So if we go look at our experiment right here, there's this overview page, and it says no data to plot. So we have this whole metric set up, but our throughput's not listed there. That would be nice if we could get that there. So let's do that. To do that, we go to this, and we're going to have to call out to Determined's core API. So I'm going to go ahead and import Determined. And then I'm going to just add a little bit down here. In order to use the core API, we're going to need to initialize it. So we use this with block with that core.init to get a core context object that we're going to use for all of our core API calls. And then I just need to make one call here. I'm going to call a function called report training metrics. And for metrics, I'm going to report that throughput. And as you might guess from report training metrics, the experiment abstraction was originally designed around doing training runs. So there you're going to have a lot of metrics that you want to report over time, right? For each step of your training or evaluation, you might want to report something. But here, we basically have a single thing that we want to report, a single data point. So there's a steps completed argument here. I'm just going to call this step 1. And our whole experiment's going to have this one step of generating that throughput. And my editors reminded me I need to define throughput. So I need to grab that out of here and then use that there. Awesome.
Corey, would you mind increasing the font size?
Oh yeah, great call.
Control equal. Yeah, there you go.
How is this? Is this good?
That's a little better. Can you do one more without
Let's
it?
do one more.
Yeah, that's great.
Okay, great. Okay, awesome. So once I've done this, I can switch back over, and I've now got my single data point shown on this graph. Okay, big deal. I can see my data point on the overview page. That's nice. You can also see the data point on like symmetric comparison pages and that sort of thing. Where this is really going to come into play is when we want to do hyperparameter search. So our hyperparameter search is going to use this, we're going to, we're going to want to be able to see this in this chart down here. And when we do a search over different variations, that's going to help us see things more clearly. If I click all here, you can see I've got a chart entry that shows this. Okay, cool. So let's now go back. Our next step is going to be to actually do some search over variations like I was just talking about. So I'm going to change my YAML file, and I'm going to add a new section called hyperparameters. And I'm going to add a single hyperparameter for now, the data type that I use when performing model inference. So these are a couple of options, either using full precision or a mixed precision, or a bfloat mixed precision. So I also need to change my searcher to do a grid search now over those options. And I'm going to tell it the metric I care about there is throughput. So if I go here, I have that hyperparameter that I've defined in my YAML file, but I need to make use of it somehow. So I can grab that from the environment. Hold on. I need to grab the right code here. There we are. So I'm going to grab those hyperparameters by calling out to getClusterInfo.trial.hparams. So this is just going to be a dictionary now containing the hyperparameters for this instance of the trial as it's running. And what's going to happen is that determined will automatically launch multiple trial instances with all of the variations that I've defined. So I need to use these hyperparameters to select the data type for my model. So I actually need to move this up higher. There we go, because this is where I'm going to use that data type. And I specified a dtype parameter. That goes into my call to from pre-trained to create my model. And here's what I'm going to do with it. I'm going to get that data type from the Torch module. So this could be something like torch.float16. All right, awesome. So I can go now to my list of tasks. And here's one where I've done this search over multiple potential items. I have bfloat, I have float32, but my float16 seems to have run into an error. Message file directory. Some weird things happening there. Apologies. I'm going to blame this on cluster mischief with the new cluster as well, and I'll debug that later. But you can see I can now do a comparison of my different throughputs. Okay, cool. So let's do the same thing now, except let's think of some other comparison we want to do. So one comparison you probably care a lot about is which model should I use? Like how fast are my different models? So let's add a new hyperparameter. To my configuration file called model name. And here I've given the original GPT-2 model we were looking at, and a couple of variations on OpenLlama of different sizes. So I might be interested in how my throughput is changing as I select larger models. Again, I need to make sure I use this hyperparameter in my script. So where's that going to go? Well, that's going to go here where I'm using model name. So instead of using a single constant, I will instead just use hframes model name instead. I can go ahead and delete this. Okay, great. Some other changes I need to make here. For the OpenLlama model, I actually needed to add a few more dependencies. And in a more structured project, you would probably move these dependencies to a external requirements.txt file and call them from there. So I needed accelerated incidence piece. Okay, great. So if I go over to look at what that looks like, let's see how these different models do. That would be my search model experiment right here. And we can see I actually ended up adding a batch size to this experiment as well. You can see the speed, if I look at batch size 1, is definitely going down as I go from 128 for GPT-2 to 32 for the 3 billion model to 17 for the 7 billion model to nothing for the 13 billion model. And this is actually due to an out of memory. So if I go take a look at the experiment, which I can, or the trial, which I can click on from here, and I look at the logs, we'll see a CUDA out of memory error there. So these are all running on a single T4 GPU, which has 16 gigabytes of VRAM, and these 13 billion models just won't fit. So that's good to know. If we look at batch size here, so let me sort by model name, I'm getting some speed up from using larger batch sizes, which is not surprising. The speed up is not quite linear. So going from 32 to 409 is not quite multiplying by 16, but it's pretty good. So as long as I can fit stuff here, doing larger batches is great. You might only be interested, depending on your use case, on the batch size equals 1 case though, because you might really be interested in what's the fastest response time I can get on a single sequence. For instance, if a human is on the other end waiting for these results to stream out, you're going to care about getting a fast streaming generation speed. But for larger scale batch inference, this is great. Okay, awesome. So our next thing is these are all running on a single GPU. I set that resources.slots to 1. How could I leverage multiple GPUs? So I can show that here. Let's go back to our code. So first thing I need to do is I need to tell Determined, hey, I want multiple GPUs. Given just changing this value, what will happen is that Determined will launch a single container on each node that has up to that node's worth of GPUs. So my node size for this server is 4. So I'm going to run 4 to get a single node. If I wanted to run on more than a single node, I could increase this further in multiples of 4. But then I'm going to have to worry about coordination between those multiple containers that get launched. And we'll talk about that in a little bit with DeepSpeed that has some features for that. But For right now, I want to stick to a single node, so I don't have to worry about that. Okay, so what other changes do I need to make? Well, if I go to my script, when I load my model, right now, this is loading on a single device. There's an easy way to use multiple devices with Hugging Face, and that's this device map auto option. And what this does is it will try to find any configuration it can of splitting your model across multiple devices so that you don't run out of memory. Another thing I need to do here, since I am using more than one slot, is I need to tell Determined how I'm using that slot. So we have support for things like Horovod, PyTorch distributed, deep speed, or running in a single node like this. To run in a single process like this across multiple GPUs, we're going to use this determine dummy distributed context object. And if you're using deep speed or PyTorch distributed, there would be a call to a function called from deep speed or from PyTorch distributed here that you would use instead. All right, awesome. So that's basically it. So minor changes, and now we can make use of multiple GPUs. And if we jump on over, and look at what that looks like, I can now see, hey, that 13 billion model, I can now run that. Some disappointing results, though, are that if you look at GPT-2, it's actually slower in this configuration, not faster, despite using 4 GPUs. So device map auto is great for making use of the GPUs you have to not run out of memory, but it's not great for getting good throughput out of those GPUs, for getting good performance. So we're going to need some fancier techniques to try and get some better performance. One of those fancy techniques is deep speed inference. So let's take a look at what we need to do to make use of deep speed inference. So deep speed is a general library that has a ton of features for speeding up both inference and training. It supports tensor parallelism, pipeline parallelism, Zero, if you've heard of Zero, which is a form of sharding. It supports, I'm not going to keep trying to list things. It supports a lot. So we're only going to make some very limited use of features in this section, but just know anywhere you want to use deep speed, we have some built-in support for it in the ways I'm going to show you. So let's take a look at this script. So we're going to need some changes to our configuration file. The first change we're going to need is we have a custom pre-built deep speed image, and we're going to make use of that. You can certainly install or build your own deep speed image. This image has some nice things like some pre-compiled kernels and guaranteed compatibility with everything along the line. And compatibility with versions is a big issue with deep speed. There's a lot of headaches that you can run into with trying to make use of that. Another small change I need here is a bug fix. This version of deep speed, I need a specific version of setup tools to make it work. More headaches, which is fun. This is actually specific to the deep speed Hugging Face overlap. So it's using Hugging Face with this version of deep speed means you need this fix. Great, great fun. Okay, awesome. And now I'm going to also add, oh, sorry, I might have been clicking on the wrong screen. I apologize for that. Yeah, okay, we're good. I'm going to also add some arguments that we're going to use in deep speed inference. I'm going to put this in my hyperparameters. Hyperparameters is just a general section you can use to pass anything you're going to want to change to your model. Here I'm going to give a model parallel size of 4. This is going to tell deep speed inference that I want to make use of 4 GPUs. I'm going to use a float 16 data type, so we'll go ahead and set this to float 16 as well. And I'm going to tell it max out tokens. This replace with kernel inject tells deep speed I would like it to try and use the custom kernels that it has internally, which are built to go faster with DeepSpeed. I'm pretty sure this actually fails for our OpenMAMA model here. So another sort of point is that not everything is supported automatically, and you might have to build a custom injection policy. But luckily, this is still going to work for getting us better usage of our 4 GPUs, even though it doesn't have those custom kernels working. Okay, awesome. So now what do I need to change in my script to make use of DeepSpeed inference? It turns out not very much. The main thing is I need to change how I load my model. So So instead of just having this call to AutoModel, I'm going to need to wrap that up a little bit. So my IDEs remind me I should import DeepSpeed. And then I'm going to wrap my call to from pre-trained in this with DeepSpeed.onDevice, device equals meta. This is going to tell this to not actually create the model fully yet, but to use meta for tensors in the meantime. Then I'm going to use this call to DeepSpeed init inference, and I'm going to pass those arguments for my hyperparameters. And then I can grab out the model using dsengine.module. But I don't really need to change anything about my generation code. That's going to remain basically the same, because this model is going to work just like any other Hugging Face model for generation. So it's great. We're able to wrap it up and then not have to worry about it from that point on. I will need to change that thing I mentioned earlier. This call, I was using this dummy distributed context, but now since we're using DeepSpeed, I'm going to have to call this function from DeepSpeed. And I'm going to have to use our custom DeepSpeed launcher in this script. So it's going to look like this. I'm going to wrap my Python call to the script with a call to not that determined.launch.DeepSpeed, which is a launcher we made to work with our system that takes care of setting environment variables, copying over files that DeepSpeed needs for initializing SSH, and all that sort of thing. Stuff that you would manually have to deal with if you were wanting to set this up outside of determined. Okay, cool. So one other subtlety here is now we're using that DeepSpeed launcher and we're using this from DeepSpeed. We're actually not running a single process anymore. DeepSpeed is going to launch one process per GPU. So this code is going to run in 4 separate processes simultaneously. So if we ran it as is, we would get 4 separate printouts and we get 4 separate calls to this report training metric. And what we'd really like to do is unify all those into a single printout and a single call. So to accomplish that, we're going to use another feature of Core API, which is that we can use NPI-like operations like gather and all gather. So I'm going to call this core context.distributed.gather, which will take this total number of tokens generated as an integer that I'm getting as an output here across all of the different processes. And then in the rank 0 process, this will be the list of those. And every other process, this will be none. So now I'd like to only perform this logic if I'm in the rank 0 process, rank being just an arbitrary number that we assign to each of these processes. So if we have 4 of them, we'll have rank 0s, 1, 2, and 3. So I can check which rank I'm in by calling getRank. And only if I'm in rank 0 will I bother doing this logic to report things. And the thing I want to report is going to be based on not this list, but the sum of that list. Cool. So this is how you can share results. Here, it was a simple integer we were sharing, but you can also share any pickleable object across your processes. Cool, cool. Okay, and if I go over to take a look at the results there, okay, I got some results for 3 billion and 7 billion. I actually ran into some issues with GPT-2 being not supported. So that's another thing you can run into with DeepSpeed and Hugging Face is sometimes support is just iffy for these things. And this is an issue with a lot of different inference libraries that support varies wildly, and you really need to check in your specific models what's happening. And then on 13 billion, I'm actually still hitting that out of memory error. So this didn't help us with avoiding this out of memory. It did help us, though, with going faster. So if I look at the throughput on Llama 3 billion here, I get around 130. And if I look at the throughput on Llama 3 billion back here, I was getting 27. So a lot faster. I'm making a lot more use of my GPUs. If you figure out the injection policy correctly, then DeepSpeed may be able to shard this model. And I think we could probably fit this on these 4 GPUs as well. Unfortunately, I ran out of time before this talk to figure out exactly the right injection policy for OpenLlama. Okay, awesome. So that's DeepSpeed inference with Tensor Parallel, which can get us some speed up. And if we play our cards right, maybe help us avoid out of memories, but it depends on model support and how much work you do. Another use of DeepSpeed that you might be interested in is how do I cram as much as possible onto a single model? So this is where sharding can come in, and specifically sharding with parameter offload. So that's going to be this DeepSpeed 0 experiment. To accomplish that, we're going to not have to change very much, mostly just how we load our model. So DeepSpeed is a big library that's got a lot of different ways to use it. So this is going to be another way to use it. By the way, all this code is public, and I'll make sure to get that shared in chat before we're done here. Oops, I think. So let's see what changes we need to make. First of all, I'm just going to change how I load models. So I was using this init inference call. I'm now going to initialize DeepSpeed a different way. I'm going to use just DeepSpeed initialize instead of init inference. This is because DeepSpeed's inference module doesn't support 0 sharding yet. There's an issue. Hopefully this will be supported at some point in the future. So we're going to use DeepSpeed as if we were going to use it for training. But we're just going to set an evaluation mode, and that's going to work just fine. And then for parameters, I'm going to pass in this DeepSpeed config. We'll see what we need to put in there in just a second. I'm going to make some slight changes to this. I'm going to get rid of this DeepSpeed on device stuff and just, we're only on a single thing anyways here. So we're just going to do this like normal, load it, move it to the GPU. And then one other thing we need to do, this is a huge gotcha, is before we do all this, to make sure Hugging Face does the right thing when we call from pre-trained, we're going to create this object called hfdsconfig. And that's going to have the same configuration that I'm using down here. This object is not passed in anywhere. You don't pass it to any functions. It just needs to exist while you make this from pre-trained call. If you don't keep it in existence, then when it's garbage collected, it won't be stored by Hugging Face in the backend, and then this call will not work correctly. So Hugging Face actually uses a weak ref in the backend to make sure this exists while this call is happening. I think this is very bad library design, but it's what we got. So there it is. Okay, tips and tricks. So configuration-wise, we're going to try and fit things onto one GPU, like as much, how big of a model can we fit on one GPU using these techniques? So let's go back down to 1. Another annoyance is I needed to fix the transformers version to get compatibility with our version of DeepSpeed. So that's going to be, what version is that here? I'm going to wrestle with my IDE in the window that you can't see. Okay, 4.29.2. So let's go ahead and fix that. And then I'm going to get rid of these inference arguments and instead use a DeepSpeak configuration more similar to what I would use for training. It's going to look like this. And what's this doing? It's using float 16. We're going to use the zero optimization. This is the sharding. Stage 3 is the parameter sharding stage, which is what we're interested in for inference. Stages 1 and 2 have to do with sharding things that are only used for training. And then we're going to enable offloading to CPU memory so that we don't run out of GPU memory while we're doing this. So this is going to save us in 2 different ways. One, the stage 3 sharding is going to hopefully reduce the usage of memory on each GPU. And then this is going to make really sure that we don't run out of memory. Okay, and I also have to set a batch size here as well. So we'll make sure that's consistent with the batch size we use in our script. And that's it. We just had to, again, we just get a model that works like any other Hugging Face model. We just had to change this model loading code a bit, and we had to use that DeepSpeak config. So let's go take a look at what that got us. All right, so one of the initial things you can see, I actually did some multiple batch sizes here too, so you could really see how this is going, is Llama 13 billion now works. So that's great. We were able to fit a bigger model by using this zero sharding. You can also see that batching, if you look at these numbers, it's actually giving you super linear speed up. It's actually faster than multiplying by 16 on a lot of these. Here it's about 16. Here, I think it's a little bit more than 16, but it's not sublinear like we saw before. And that's because we're really not making very good use of the GPUs when we use this sharding with offload in this case. There's too much traffic involved with using zero with offload and too much of the CPU memory being slow. So we just get really like bad performance results in the single case. Like compare this 10 to what we were seeing before for GPT-2, which was in the hundreds. So offload is super slow, but if you need to fit something into a single GPU, you can do it with this sharding plus offload. Cool. All right. Last thing I have to share with you, and we won't go too into depth on the code on this one, so we leave some time for questions, is how would I, so far I've just been generating from an empty string. How would I actually like use a batch of data that I care about and send that, like plug that into the system? So what we can do is I can create a data set over here. Let me copy this data set I have. Nope, not new folder, new file. And you can pull your data sets from anywhere inside of your script. You could pull from S3. You could pull from Databricks or wherever. But here I'm just going to create a very simple data set of prompts that we want to ask about. So we want to know what 1 + 1 is equal to. We want to know the value of sine of pi. We want to know the current time, which language models should not be very good at answering because they don't know what time it is. But these are some questions that we have. When we submit an experiment, we can include data sets in our context so long as they fit within the experiment size limit, which I think is currently around like 90 megabytes, 100 megabytes, something like that. So for small data sets, you can submit them directly to Determined. For a larger data set, we would probably like put this in S3 and pull it from there or something like that. You don't want to be manually passing large data sets anyways around too much. Okay, awesome. So I've also made some changes to the script. What did I change? Well, I'm going to, let me scroll down. I'm actually going to read that data set using pandas. And I'm going to turn it into a torch data set. So this code is going to use that deep speed inference tensor parallel and run on 4 GPUs like we saw before. And I want to make sure that I distribute this data set across those GPUs. So I can just use Torch's distributed sampler to do that, and then turn that into a data loader. And this will make sure that no 2 processes get the same sample. I'm only doing each of them once. That I'm efficiently splitting those up. So I can change my generate function to, instead of taking in a size, I can just pass the thing that I want to inference on directly. And then I can gather up all my results. And down here, what I can do is I can use another feature of Core API. I can create a checkpoint. So we're going to use the store path function. And we can dump our generations and the prompts that led to them to a CSV file that comes from the path returned by that store path function. There's a lot of junk around here, like we need to pass metadata to let it know. Again, we might want multiple checkpoints if we were doing a training run. So we have to know at which step this is a checkpoint for. And then as a return, it's going to give us both the path that we should write stuff to and a storage UUID that we can use to reference this checkpoint later. So if you wanted to recover this checkpoint later in the same process, you could keep track of that and use it for download. And then once this with exits, once this context manager exits, then everything you've written to that path, to that folder, will be uploaded to Determined. We could go check that out in our UI. Yep, here I've got a couple of experiments that I've run. I can go in here and I can see here's a checkpoint, and it's got this generations.csv file inside of it. And I can use this UUID right here to download to the CLI or using our Python API. Okay, awesome. That was a huge data dump of code. We've got some time left. I'm happy to go back and revisit anything that anyone wants to see or talk more about. If not, thanks for listening.
Thanks, Corey. That was super interesting. Let's see. Check. Any questions? Some questions about upcoming events.
Oh, I see a Q&A tab.
2 questions about receiving follow-up. I recommend joining our community Slack. The Slack button is on the top right at determined.ai. You can interact with the community and it's there. And in about 6 minutes, we'll be breaking out into Birds of a Feather session. We've got 2 of them. One focused on kind of ML theory and training, and then the other one focused on systems and infra. So feel free to join either one of those. It's going to be very interactive. So with those, if you have a question, you can ask and say your question. I want to come off mic or cam, and we'll bring you into the discussion, and we'll have kind of a back and forth. I don't see anything specific, Corey, regarding your presentation. Alex, did you see anything?
Yeah, it looks like there's some in the Q&A tab that I think, Corey, you can see those, right?
Oh, in the
Yes.
session Q&A tab.
Yes.
There we go.
So I just posted the link for all the code for this talk, if anybody's interested. I see that was one of the Q&As, so that's in the chat tab. Click over there to grab that link. Let's see what else. Let me actually put it as a reply to that question as well. There we go. Can I change the tokenizer translation of words into tokens, or every model has its own token? I think we talked about that earlier. Every model is going to have its own tokenizer that it was trained with. and you're going to want to use that tokenizer. If you want to train your own model from scratch, you can go ahead and create your own tokenizer that it's going to be trained on. But once something's trained, you don't really want to change that. So if I want to add, so this is from Aviator Levy. So if I want to add a new language support to pre-trained LLM, and I want to have a different tokenization, what can I do about it? That is a great question. You can add new things to the tokenization and do a fine tuning. And your base model won't know anything about those, but you can eventually fine tune to that. If you want to change the existing tokenization, it's pretty fraught because the model is like not going to understand why words all of a sudden mean completely different things. I am not familiar with just flat out taking a completely different tokenizer and trying to fine tune. It's possible that might be better than training from scratch. I imagine it would be because maybe it wouldn't completely destroy the model structure. But yeah, not super familiar with doing that. So you can add things though. So also a lot of the foundation models that you might use are probably trained on multiple languages. So that's definitely a thing you should try and use if you can. And the tokenizers that they have will cover, I think, any like Unicode use case. They'll like normalize down to something. It's just, it may lose some information. So I think your best bet is probably, if needed, add to the tokenizer, but don't change the existing tokens. If I want to retrain my LLM model in the latest state every month, should I use the latest model and tokenizer every time, or using the base model tokenizer is recommended? When you fine tune your model, in general, you'll just keep the same tokenizer as the base model. So you won't be training the tokenizer. You'll just be training your model. I am not an expert on adding languages to LLMs, so it's possible there's techniques there I'm not as familiar with. What about doing full fine tuning, change tokenizer? No, again, I would just leave it the same. Cool.
All right. And Corey, there's a couple more in the chat that are kind of determined specific. When we run determined AI on a single node and create the cluster, and then there's one about differentiation from NVIDIA, if that's your area of expertise too.
Great. Can we run determined AI on a single node and create the cluster? You can certainly run determined AI on a single node. So your master will also run on that same node. This is assuming you have like an on-prem node or an EC2 node that you're going to like manually install determined on. But yeah, you can definitely do that. You'll be sharing resources between the master and the agent that you launch on that node. How is determined different from NVIDIA Dask, which is used for distributed processing? So Dask, if I recall correctly, is an abstraction over, I forget what type of thing, but it allows you to do sort of like Spark-like distributed computations. You can certainly do things like that with Determined, and you might be able to hack Determined to run some Dask stuff. Determined is about the Docker container launching, or the management of the cluster, and then the core API features like experiment tracking, metric tracking, hyperparameter search, checkpoints that you have available from within those Docker containers. So that stuff is more of a like set of tools you could use to build your distributed processing. And for specific things like DeepSpeed and PyTorch distributed, we have both our trial classes.
I think we may have lost Corey.
I think so too.
Looks like I got kicked off there for a second. Can everybody hear me?
Yep. Oh. Let's see if he rejoins.
Yeah.
Hi, Shive. I let you come off mute if you do want to ask a question.
Can you guys hear me now?
Yes.
Okay, sorry about that. I don't know what's going on there. Okay, one more time. Determined AI, launch processes, do experiment tracking, do checkpoints, that sort of thing. Dask is more like a PyTorch distributed type thing, except specific for numerical computations instead of like LLM training. Both of those could fit and be used sort of from Determined, I think, although we haven't done a Dask integration. But yeah. Okay, are you considering using WebAssembly to optimize running LLMs locally? I don't think so. I don't think we have any plans about that.
Yeah, so actually, I have been kind of running some experiments myself for running Llama 2 with this WebAssembly runtime called Wasmich, and that has actually shown a lot of improvement. And there's also this company called Fermion, which is actually they have launched a service called as Serverless AI, where they are essentially running the LLMs on dedicated AI enabled Kubernetes clusters, but of course they're again optimizing that with WebAssembly. So at least in the past few weeks, there has been a lot of chatter, at least in the WebAssembly ecosystem, related to being able to run LLMs as a serverless functions or being able to optimize them locally. So I was just curious to know if the Determined team is planning to do something around this.
I think that sounds very cool, but it doesn't necessarily interact much with the cluster management. So if you have a ton of GPUs on your cluster somewhere, I think Determined is primarily around how do you leverage those, right? How do you leverage those to serve inference elsewhere, or how do you leverage those to perform distributed training or that sort of thing? Whereas what's running locally in the browser is going to be more independent of what backend cluster resources you have available. So I think that's one reason we haven't really looked too much at that. That would be an interesting thing, though, to we do training in the backend and then allow you to serve in the browser. So I think it's interesting from that perspective. But yeah, we haven't looked at that. That's a good suggestion.
Thank you. Thank you.
Yep. Cool. That's all I have. So thanks, everybody. Hope you enjoy the next session.
Thank you, Corey. Well done. See everybody over in Birds of a Feather.
All right, Jimmy is joining. Jimmy is on his way. All right, let's go ahead and get started with our introductions. Then when Jimmy hops in, we can introduce him. Hi, everyone. Thanks so much for joining this panel. This will be a panel discussion on ML tools and techniques, but we also have some fun questions lined up about LLMs and just AI's role in society. My name is Isha. I'm a machine learning developer advocate here at Determined AI. One of our panelists is here with us. We're waiting for our second one. But Kevin, I'll let you go ahead and introduce yourself as well.
Yeah, thanks, Isha. So I'm Kevin, and I'm also a machine learning developer advocate. And I actually just recently joined the company a month ago. I graduated from Cornell with a PhD in ML.
Cool. Awesome. Yeah, we'll wait for Jimmy to join. So I just want to make sure we ask all the questions to both of you all. But also, this is interactive, so if any of the audience members have questions, feel free to drop them in the chat. You can also come off of mute and off cam by clicking share audio and video. That's allowed as well. So we'd love to have you participate. And this is just a very informal session talking about anything within this domain. Hey, Jimmy.
Hey, how's it going?
Glad you're able to join.
Hi, Jimmy.
Good. We just did quick introductions, so if you want to go ahead and introduce yourself, and then we'll get started with some of the questions.
Yeah, sure thing. So hello, everybody. My name is Jimmy Whitaker. I am the chief scientist in the AI and strategy group here at HPE. So actually followed on with the recent acquisition of Pachyderm, so I was chief scientist there for a little while. Overall, my background is kind of heavily in machine learning and also doing machine learning at scale, and also just from a process perspective, kind of across organizations, really. So my background is really NLP and speech recognition mainly, and building out models for that, in particular in financial institutions. And then by doing that for a little while, I realized we were trying to solve more data problems than anything else. And that was keeping us from really trying to do compelling things with machine learning or machine learning techniques or tweaking our models and tuning them. It was mostly all data problems. So that's when I shifted over and joined Pachyderm to try to solve that aspect. So data versioning and data processing and getting your data ready for model training has kind of been a huge part of my background and the things that I'm sort of passionate about solving, because I ran into those a lot, both from an engineer perspective, a manager perspective, and even director and stuff like that. So it's a complex thing. So yeah, so I'll shut up. I can talk about that for way too long.
Thank you so much, Jimmy. So I'm really excited about this session. This should be a fun session. We have a lot of interesting questions lined up. And I already told the audience, feel free to jump in with any questions that they have. But we'll start with some of our pre-prepared questions. So let's go with an easy one to start. Since this session is called ML Techniques, I just want to know, what are some of your favorite ML tools or projects and why?
I can go.
And
yeah.
Either one can start.
So yeah, my answer is going to be maybe disappointing or generic, because so I went through a lot of, I went through grad school for a long time, and the tools I use were basically like PyTorch, Torch Vision, Augmentation. So that's like an image augmentation library. Feist, maybe that's a bit more exotic. So that's like a nearest neighbor search library. But beyond that, it was pretty much using those like building blocks and then building my code on top of those. So I didn't actually interact too much with like more specialized libraries. So I wrote some of my own libraries. Didn't go into. Oh, I also used what's another good one is what's it called? Torch image models. TIM. Right? I think everyone uses that one. But yeah, so mainly just the sort of the bread and butter of machine learning.
Cool. Yeah, there's probably a lot of similar ones for me. So yeah, I've been a heavy PyTorch user for a long time. One of my, it's not really a claim to fame, but one of the hilarious things was Sumit Chintala, who was one of the creators of PyTorch at Facebook, was or is a friend of mine, and we would we would chat about the PyTorch stuff early on when he was thinking about it and rewriting Torch 7. I actually used Torch 7 a whole bunch with the Lua days. And yeah, things have come a long way, and it's actually really exciting and cool to see that. And then it's kind of been all over. I did a decent bit with Torch Lightning, obviously the Transformers library with Hugging Face more recently. But there's just a lot of great libraries out there. Things are getting really cool. And I tend to be less on like the getting heavily optimized. It's more like what gets me going quickly, and how can I solve the problem? I'm maybe too pragmatic in that regard. So if there's a library that gets me ahead, then I'll try it out. More recently though, just like tooling wise, I'm loving seeing all the LLM stuff. I think we're getting onto some of the LLM conversations here in a little bit, but there's some really cool tools that are pulling those together just from a like code completion perspective, or just like even finding out new libraries. I think ChatGPT will give me a new library that I didn't know about almost every day. And that's even for like the 2021 days where that data set comes from. So yeah, there's some cool stuff there.
Have you used, I haven't used LangChain. Have you used it? Just curious.
I have. I actually really like LangChain from, I used it for kind of a pet project or like a toy project on my own, but scalability seems questionable, but for like I was using it to do like a docs bot or a docs kind of Q&A bot. And it pulled, I had it pull a GitHub repo and then grab all the markdown files out of the GitHub repo, which are like, you know, readmes as well as the docs pages and everything else, slice and dice that, and then do like a document retrieval Q&A bot. But yeah, it was like the heavy lifting code using LangChain was, I don't know, like probably 20 lines. Like it was kind of astounding compared to what I'd done before. But I think like if you're going to scale that out and do like massive scrapes and stuff, then you're having to write some orchestration code, which then makes the simplicity a little bit harder to you know, generalize from.
Yeah, it seems
That's
like
so interesting.
yeah, it seems like
Go ahead.
one of those things that it can really simplify. I think for like simple applications or like simple like getting into the like your first LLM application or something, it sounds very convenient. But I've also seen, you know, I can't judge because I haven't used it, but I've just seen so many people like hate on it on Twitter,
Same.
and I don't really understand why, but I guess maybe they're trying to use it in a bigger scale application or something. I don't know.
Yeah, maybe so. I mean, there's always going to be, there's a critique on society, I think, more than anything else. But people are always looking for like a hot take or to be controversial. If you view something and it's actually been really beneficial, you're probably going to like, what's the rule of 10? Like if you're really satisfied with something, what's the likelihood you're going to actually write a review about it? But if you're really dissatisfied with it, if it's like a 1, then you're probably not. You're probably going to write it quicker.
Yeah.
So.
I'm actually curious, does LangChain replace anything, or is it in its own niche and like solving like this newer problem of like LLM ops per se? Like I'm just kind of curious, like is this like a replacement at all, or is it just kind of a new thing?
So, well, Kevin interrupted you. It looked like you were about to say something.
Yeah, from what I can tell, is it okay? I mean, it was you're saying was there a library before this, and does it replace that?
Right, like yeah, does it replace, or is it in its own niche? Is kind of what I'm asking.
I think it's like a new cat sort of thing, and it just like brings together a bunch of tools into a easy to use API. It's that kind of thing, and it you know makes it easy to call. You know, it's basically wrapping other functionality, but it's just done in a nice way. As far as
okay, that's the impression I got. I was just curious but that's so super interesting to hear your take, Jimmy, because I've also seen people hate on LangChain because I think the usability factor, like people can't figure out how to use it maybe, but yeah, that's completely right.
It's kind of interesting because I would say the usability was probably the biggest selling point to me. Like for instance, and maybe I was doing something, maybe people are doing more complex things than I am, but like pulling data from a particular source, like doing some type of like slicing and dicing on that, like splitting and chunking and those kinds of things, embedding that into or extracting embeddings and then putting those embeddings into a document database and stuff like that was incredibly simple and easy for me. And like surprisingly simple. Like I think I ran into a few issues here and there, but they were very well documented. I think they're even using like the LLM, kind of the same thing I was building in their docs themselves. So you can ask it how to do something and it'll generate some code for you based on the docs that you're using, which is where it's all going anyway. But it's a lot of fun to kind of see it in action. But yeah, so like to me, it's like very much just the glue code. Like you can use I was using OpenAI embeddings for that, and so just set an environment variable for your OpenAI API key, and then import the OpenAI embeddings module, and then just tell it what you want to create embeddings for, and it just spits it back. And then you can use it for stuff. So to me, it was really simple. I've definitely liked that tool from, especially from like a prototyping standpoint. I've seen some people complain about like, oh, okay, once you want to go from that to, okay, I now want to do this at like a massive scale, parallelizing something that's got really nice glue wrappers around things, tends to be a little bit more tough. Unless you're like discretizing the data up like in front of things. If you're trying to get it to scale out in code land, then it starts to get a little bit weird. Sorry, I might be all over the place with that one. Hopefully that makes sense.
No, that is a lot of great information. And actually, it's a great segue, this discussion about LLM tools, into my next question. So with the next question is, with code LLMs on the rise, where do you see the role of software developers going in the next decade? And to follow up with that, will sites like Stack Overflow still exist in your opinion, and Q&A and blog websites? Where do you see those going with the rise of LLM tooling and code LLMs?
Yeah, okay, I can go. I think that, so right now, I'm finding that it can be really useful. So like one thing I did recently was there was some JavaScript regex, and I needed it in Python, and then I just asked GPT to convert it, and it actually worked. So that kind of thing, it's extremely useful for. And I guess just generally anything that's been written about, a lot online, which makes sense because that's that's what's training on. But yeah, the more complicated things you ask it, it's going to be more error prone. So I don't see it. So in that sense, you can't just ask an LLM to just like write your code base and then just you're going to be done with it, right? So they're not trustworthy enough for that, and therefore, software developers still have to be involved. So right now you can use LLMs to help, but then you're going to have to basically proofread it. And also for more complicated things, it feels like it's probably just easier to write it instead of like coming up with the perfect prompt. Now, as the years go by, I think that they're obviously going to get better, and so people are going to start trusting them more, I think. But they're still not going to be 100% trustworthy. So I think maybe software engineers are going to transition more into like writing testing code. I don't know, but this is one possibility. Is they're going to get LLMs to generate a bunch of code, and then the engineers are going to be the ones writing the testing code. And then if LLMs end up writing the testing code also, then maybe the engineers will write like the code that tests the test, like mutation testing. And then beyond that, then maybe software engineers will disappear. But in the next decade, I think there'll still be engineers, but I think there might be a shift into like more maybe like writing tests. But it's hard to say, I guess, because it really comes down to how trustworthy they are, the LLMs.
Yeah, I'll just add on to that. I think that's right. Like for me personally, just for instance, on the ChatGPT side, it's turned me from a writer into an editor. And so like there are still things that it gets wrong. If you're an expert in something, then you know what you want, and it's going to make you more powerful, like as far as development goes. But at least when I'm talking to people in other industries, I get asked this question a lot, like, oh, are software engineers going away? Whose jobs are obsolete and stuff? And I kind of keep saying like, oh, okay, it's like the introduction of Microsoft Excel to the world of accounting. It's a new set of tools that like is going to make some people obsolete, but it's also going to let you become capable of a lot more. And so, yeah, so we may end up shifting shifting more away from like writing boilerplate stuff into more editing some of the boilerplate, or figuring out like, oh, okay, I'm getting this error, I can feed this error back in, and maybe that there will be another suggestion. Like, I don't know if anybody's used some of the like Open Interpreter or some of the Auto GPT stuff that started to come out recently, which are very, very interesting to me. I mean, they'll blow up your OpenAI API bill if you use it for too long, because it's doing tons and tons and tons of requests, but it'll debug the code as it's running the code for you and all kinds of other things, which are becoming really interesting. But yeah, I always hesitate to do a this is where the world is going, because hindsight will always be 2020, but it's I don't know, it's kind of a little bit of a shot in the dark, at least for me. I don't feel confident about my future predictions, but just from my experience so far, like I think it's going to be people that learn the tools and really dig in on the tools. I think productivity has the potential to go through the roof, but there's also a risk of like antiquated techniques, or this is the way I've always done it, don't make me learn something new. Then yeah, that's kind of always been the case, I think, like historically. Using the newest tools or rejection of the newest tools is going to make you less efficient over time. And that's kind of how it's going to go. As far as Stack Overflow, I think Stack Overflow is probably one of the more interesting use cases to me, because so much of that was the discussion place where people were trying to solve problems. And those have also been like so heavily used in the training of some of these coding models. And so I'm kind of curious, like, where does that discourse go now? And that's going to be really interesting, because there is like a curiosity that I've seen in other places. I'm not making this up, but basically, if up to now the LLMs have learned entirely from humans to some degree, or even from human preference with RLHF and those kinds of things. But then when we get to I mean, if we're fast forward like 10 years, is the bulk of the data that's on the internet written by LLMs? Like it becomes like a really interesting thing, is like the majority of what's out there generated. And so therefore, are we actually getting anything like the compression of data or the usefulness of data that someone chose to write goes down a little bit. For people to write blogs, it's quite a lot of effort, and they have to really be thinking that they're providing something valuable to some degree. But it does that go down a whole bunch when we're just generating things because it's easy.
Yeah, if people are going to start writing blogs, but actually like most of it's just written by GPT, then it's not. It's not.
Yeah, it's just feeding itself. It's just
yeah. And oh yeah, and I also read, so there was a sort of a viral thing about Stack Overflow, how the traffic dropped by like 50%, and then they came out and said, no, that's not true. So I don't know, they said it's down 5% since 2022. That's what they're claiming. But I can definitely see, because just like Googling things can be pretty annoying a lot of the time. Like, first of all, you might get irrelevant search results. That's a big problem. But then even if you go to Stack Overflow, like there might be a bunch of answers. And then if you can just ask GPT, it's just way easier. And also, that's the other thing though, you can ask it, like in my example with the regex, you can ask it exactly your problem.
Yeah.
Whereas usually with Stack Overflow, it's like, oh, it's a related problem. You got to start adapt it to your situation. And yeah, so it's a big problem.
The mental effort for that is annoying. Like if you can take out any of the cognitive load, like I feel like that is a lot more useful. Last year, I wrote this like long regex that was like 40 characters, 50 characters. It took me like a week. And now, and GPT-3 wasn't out yet. So now I'm wondering, if I had that tool, how quick would it have been? Maybe it would have just come up with that like in 5 minutes, but yeah. Interesting perspective. You also mentioned something about constructing the perfect prompt, Kevin. I don't know if you've seen this, but I've seen like prompt engineering roles. So I don't know if like the development lifecycle is going to shift towards this like cycle of prompt engineers testing rather than like traditional software development. But that was just like my view of it.
Yeah, that would be so strange if that's what it turns into. You mean like basically just tweaking the prompts until it comes up with what you want?
Right, and then test engineers, and then that's kind of like the development life cycle. I don't know, that's just like something that I just noticed, that people are getting these prompt engineering roles, and that was like months ago, and before I even knew what prompt engineering even was. So it's just interesting to see that is a development in the field. But
one of the funnier prompts I saw was something like, there's like think step by step, but there was like another one that was like take a deep breath. Like I saw.
Oh.
I find it later. It was like take a deep breath and think slowly. I'm like, how? I don't understand how that would help. But
wait, that's really funny. Are you referring to, when you say step by step, are you referring to chain of thought prompting?
I'm not sure. Maybe. Yeah.
Okay, I think so. The chain of thought prompting that I'm talking about is when you, when instead of prompting with the question in like one shot, like here's a bag of apples, and like you take out this many, like how many are left? Like it's like you start with a bag of apples, like I've taken out 2, like now how many are there? And then it's like you prompt it again, and you basically work the problem with the model, and you ask it in a series of questions rather than asking it the full math problem, for example, at once, and
Yeah.
that helps. So when you say take a deep breath, I'm wondering how does that translate to prompting? That's actually
don't
so
know.
interesting.
Yeah. It was pretty surprising to see that.
Yeah.
Oh yeah. By the way, there are. Yeah, I think Jimmy pointed out there are a few questions in the what's it? The
Oh,
Q&A.
great. I didn't even see that. Awesome. So we have one that is upvoted. In an LLM chatbot use case, what technique can you use in order to load the chat history so that the chatbot will use it in its answers?
Is that like retrieval augmented? Is that kind of thing? I don't have experience with that. Maybe Jimmy.
Yeah. Yeah, I think there's kind of there's a few different approaches. So like the retrieval augmented search, I don't know if I'm probably getting the name wrong, is the one I'm most familiar with. So basically, and it kind of gets into prompt engineering a little bit as well. So you have your large language model, it's trained on everything, and you're trying to get the best response given a particular context. And so you're trying to tweak the prompt and the whatever additional information you're providing to the LLM at the time so that you can get the best response given the context that the LLM was provided. And so sometimes this can be tweaking words or like doing different things to make the model, I don't know, choose different paths for how to actually like generate the text that it's coming up with. But for the retrieval augmented stuff, the way I've seen that done is basically you're creating embeddings and you're more or less using another LLM to create those embeddings. Usually it's all the same one. So for instance, like the DaVinci model and like the OpenAI realm, or you're using a Llama model to create some embeddings for particular pieces of text. And then when you have, say, a new question come in, you try to see how similar that question is to a bunch of other documents that you have embeddings for, and then provide those documents as, okay, given the following, and then paste in all your documents, answer this question given what I just like told you, and then it'll be able to provide hopefully a more relevant answer to specifically your question. And this is a way to kind of hack around at least where I've seen it most commonly used, a way to hack around the end of the training data date being September 2021 for like the ChatGPT stuff or GPT like 3.54 and those kinds of things. For instance, like the chatbot that I was talking about for a docs project, the docs had progressed a whole bunch since 2021, as any open source project would. And so by doing that, you could ask it questions about that project, but you could also, that's going to be out of date by about 2 years. So being able to pull the most recent information and put it in there, at least what's relevant, and then get responses based on that new information rather than what's built into the large language model, was a really useful technique for like providing the relevant, I guess, chat history, if you will, or the relevant information to the LLM to predict that thing. There's probably a little bit of ambiguity around this question because I'm wondering if it's like loading the chat history. So the chatbot can use it to answer questions. Like this could also be, are you trying to save the state of different chats, like user states, if you will, or like, this is my dialogue about this topic. This is my dialogue about this topic. And that's more of like a web app question of how you load those things up. But yeah, there's with any of the chatbots, there's kind of the preloading or like the conditioning the model more or less to be ready to start making inference. And so some of that may or may not be lost. Like there's a bunch of different techniques around this. Whether you create an embedding that's like your start embedding for your prediction going forward, or if you're just like reading a whole bunch of stuff before you start even like taking in the user question, like a ChatGPT thing, there's a prompt that it is prompted with even before you ever get to it. And then you can kind of tweak some things on top of that prompt, but you can't ever, well, there's some hacks around these things, but you can't like undo that prompt necessarily that it's been kind of baked into that deployment of an LLM. So there's a bunch of different things there. I guess is the long story short, but the retrieval augmented, I guess, search I'm forgetting the full term, but yeah, that seems to be the most common way I've seen it for application purposes.
Retrieval augmented generation.
There it is. Thank you.
Yes,
Yeah.
RAG.
Yeah.
It's the new buzzword, not DAG anymore.
Right.
Awesome. Thank you so much, Jimmy. So we have a lot of good questions from the Q&A and the chat, so I'm going to try to go through them one by one. Really quick, has anybody used pieces.app before?
I have not.
What is that? I don't even know. Pieces.
It seems that it uses LLMs to gain insights from your code snippets and provides a Copilot interface, which can be used to get more context from the snippets. I just wanted to ask in case you guys had used it, but that's, yeah.
I haven't used this one specifically. I've used some similar tools, either like baked into like VS Code or some other things. So which I think this one actually has an extension for as well. So yeah, I haven't used it explicitly, but I've used some similar things, and yeah, I mean, it's definitely the way things are going, it seems.
Yeah, it's a cool thing to try out. Thanks for bringing that up, Shibe. Next question, what according to you is the biggest hot take in relation to LLMs? And in your experience, how do MLOps engineers need to upskill themselves when trying to deploy LLMs in comparison to deploying and observing regular ML models? Do you feel that we need to make special considerations when it comes to monitoring LLM deployments in production, or is it very similar to regular ML model deployments?
Yeah, it's a lot of questions.
A lot of
It's
questions.
a pretty loaded one. No, it's excellent.
I think it's 2 parts. Yeah.
Yeah. I'll be annoying. I'll skip over the biggest hot take and jump to the more practical thing. But as far as like deploying LLMs and kind of the machine learning ops, or some people are even starting to try to say an LLM ops and all those kinds of things, there's always an ops, like acronym it seems. But yeah, so one thing I'm actively working on is deployment of LLMs and like looking at the product for how to best do some of those things and like what open source is doing and all kinds of other stuff there. So this is, I'm probably not the most well-read on it, but I've been reading a lot on this specifically up to now. And so special considerations, LLMs are, there's a lot of compute. So like optimizing and making the most of that compute is a big deal, almost more so than computer vision models, or at least other ones that I've had to use before. And so there you get into some situations with dynamic batching or like basically any type of thing to like do some interesting performance things. VLLM is another one that has tried to do some interesting things on dynamic batching, or once one prediction has finished, inserting something immediately so you can continue prediction, and because you're memory IO bound instead of compute bound, which is an interesting shift in mentality. It's how quickly you can get data to the GPU rather than how quickly your GPU can go in a lot of the LLM inference scenarios. So, and there's some interesting papers there. I'll try to drop them in the chat here in a second. But yeah, so that one I think is a really interesting one. Like figuring out that you're not compute bound, you're memory IO bound is a particular serving concern. Another one is there's different ways to use LLMs. And so the deployments can get kind of weird. Like chatbots are pretty simple to reason about, but then you may also be trying to do embeddings. You may also be needing to use those embeddings and then put those into a database. So depending on the application that you're using, and that type of database is usually like a vector database. So there's a lot of different types of applications being built with large language models. So when you get to like the end user goal of what you're trying to build for, that's when things I think start to get really interesting. Because you can just serve up a model, but you may need to chain models together, or you may be using one set of things to embed like documents into a certain database, and then another model is pulling out those embeddings and then predicting with those embeddings to do different things. So you get into these kind of more, they're going to build on top of each other, and you have pipelines of operations and those kinds of things over time. So I would say that's more just like not really helpful, but these are a bunch of considerations that start to crop up and where things get really interesting with the LLMs in particular, because yeah, just straight LLM chatbot stuff. The performance of that model or in isolation is an interesting thing. But then if you're thinking about how do I solve like a huge end problem, then you're probably not only predicting something once, but you maybe do an embedding so you can pull context back quicker, and then you're iterating on those predictions, and you're going to be predicting a ton of things consistently over time. So it gets really interesting. Basically, these models, the more powerful they are, the more they're going to get throttled with queries and other types of capabilities.
So for the hot takes,
Yeah, I was going to say,
really-
you might be the better person to have the hot takes, Kevin.
I feel like there's two ends to that. There's one that's like, there's people who think that, you know, we're entering a new like golden age, and in like 10 years everything's going to be solved. Like AI is going to solve everything for us because we're entering the singularity. And there's a lot of people who think that, but that's also, I feel like at the same time that is kind of a hot take, because everyone in the AI community kind of would probably scoff at that. And then there's the other end of that, which is, you know, the current trend. We're not going to go towards, you know, this is not the path to like AGI. And I would say I probably agree with that. I mean, there's some, even like Jeff Hinton, like saying, well, maybe in like, you know, he thought, you know, AGI is like way off, but then after seeing, you know, these new language models, you know, maybe that's closer than he originally thought. So even people like him think it's pretty close, you know, maybe within the next couple of decades. I feel like maybe that's possible, but there's going to need to be like some new paradigm. I just don't see how they're going to be able to keep building on like the current type of, you know, LLM, you know, these type of architectures to get all the way to something that can actually, something that's like truly intelligent. Because you know, when you play with an LLM, you'll inevitably come across some weird case where like it doesn't even know how to add or something, right? Because ultimately it is just, you know, predicting tokens, and that doesn't always work. So I don't see, I think there's been so much interest in this space and so much hype. So I would say probably we're not going to, like, the pace of improvement, it looks like it just suddenly it improved so quickly, and if it just keeps going at this rate, yeah, we're going to get, you know, like Terminator style stuff. I just don't think, I think that the rate of improvement's going to slow down. You know, I suppose that's a hot take. I'm not sure. The problem is that there's opinions on, it's kind of hard for there to be a hot take because everyone has, you know, all the opinions. So, but that would be my sort of take on where LLMs are going in general.
Yeah, I've kind of used the just adding onto that the I don't know. I tend to be like annoying on some of these things, but I always joke that it'll take away all your LLMs. They're going to take away all your problems and give you a whole set of new ones. And so it's whether those are like Terminator style. I think probably not. I'm not really an AI doomist, but yeah, they're going to be all kinds of things. Like if you say optimize the amount of money in my bank account, and then it goes out and starts doing crazy options trading, and with enough power that it bankrupts markets, and you get into some crazy situations, then yeah, they can have some pretty big implications. But it's not like it's optimizing for an objective, but it's still like just a powerful tool in the hands of people, somewhat at the end of the day.
Yeah, and we can talk about more of the AI doom versus not towards the end. We have some fun questions there. I just saw what you put in the chat, Kevin. This take a deep breath thing is so interesting. I'm gonna have to read the full paper on that. Wow. We have one more question in the chat. Do you see LLMs and knowledge graphs working together at scale in the future? And if so, how?
That's maybe, you mean, so like, I guess that's a way to prevent like all this hallucination stuff, right? Like just making up facts. Yeah, maybe that's
maybe
a way. But so I guess people are going to have to, you know, you have to construct these knowledge graphs somehow. You have to have source of truth. That seems like a tricky situation, but yeah, I mean I guess that, yeah, that could be one solution, but ultimately it's like, how do you construct that knowledge graph, and where does that information come from? And there's a lot of very I would say like controversial areas. Like if you're doing knowledge graph stuff, if you're having source of truth on really basic things like, I don't know, things that people agree on, like chemistry or whatever, then it's fine. But once you start getting into more controversial topic, anything like politics related, it's going to get a lot harder. But I think I see people, they probably will do it. It's just there's going to be a lot of arguments about what's best, because how does someone say, what is true in this scenario or what's not? And then you're going to have people depending on LLMs, to give you answers based on that. Yeah.
Yeah, I'm kind of with you there. Like, it'll obviously impact like queries for different things. Will like, oh, we're pulling the facts from a knowledge graph, we're providing them to an LLM to structure an argument based on these facts or something. I can definitely see those types of interactions, or generating code to operate on knowledge graphs, or even pulling in data and ingesting them into knowledge graphs, or those types of things. But yeah, like it almost becomes philosophical, to your point, Kevin, at some point. Like, what is truth? And then, like, where are you pulling that truth from? What is the bias? Like, LLMs have internet scale bias, which can mean certain things. And yeah, and we also don't have all the answers all the time anyway. So there's like, our bias might be to drum up interest in LLMs, but then that's a bias that we have that's not necessarily good or bad. It just is a bias that exists. So yeah, it becomes pretty philosophical, I think, but it'll definitely impact some knowledge graph stuff, I think, like almost certainly. I don't see an area. I think it's more just the horizon of like, when will LLMs and some of these techniques impact a particular technology, not necessarily if. So yeah, it might be like 3 years or 5 years, but honestly, there's probably some stuff happening right now with knowledge graphs, almost certainly. So.
Oh, that actually makes me think, with the source of truth and stuff, so there's been different models, like, I can't remember exactly, but I think Meta released a model, and some people were complaining that it was too cautious. So like, even if you ask it something harmless, it would say, oh, I can't answer that because I'm trained to be, blah, blah, blah. So they have people red teaming these models to make sure they don't say bad things. But that can be, they can go too far with that to me, and then the model ends up not being useful. But anyway, that generally there's people who train these models, and then they want to make sure it doesn't have biases. I'm just wondering if people are going to start training models to have like biases that they want.
Yeah,
like,
and not having bias is a bias in and of itself. Like, you're biasing the model to not have opinions.
Right.
Yeah, there's always a bias. There's no bias. Like, that's not even a scenario that exists in my mind.
Yeah, like, you don't want it to have like harmful bias, like gender bias, or like race bias, or anything like that. Especially in hiring scenarios, or any of those types of things, loans, whatever. But yeah, no, it gets really interesting, I think, with all this stuff. It's like, because bias, people are like, oh, I want my model to have no bias. And it's like, oh, okay, well, that gets into other interesting areas.
Yeah.
Yeah.
I'm curious, you said, just a quick sidebar before we get to the next question, you mentioned that you can kind of over red team a model and safeguard it too much. I think the problem is like the opposite. I'm curious if you can like safeguard something too much. Like, can you elaborate on that just a little bit before we move on?
Yeah,
I'm curious what you mean.
I don't have a specific. I'll see if I can find. There's people who are using like Llama, right? There's like a whole community on Reddit, and they ask it like, there might be examples on Twitter too, but they'll ask it like, make me a dangerously spicy soup or something, and then the LLM will be like, oh, I can't do anything dangerous, right? Which is silly. Obviously, it doesn't. That's not like. It's the question was not like a literal like, oh, I want making me a soup that's going to kill someone, right? So it's like that kind of thing where you've restricted it, or you've fine-tuned it too much, where it's not going to answer reasonable questions. That's basically.
Yeah, and also the paperclip problem, I guess, the OpenAI paperclip issue, or the example that they like to use. I don't know if that's related to this, but have you heard of that, Jimmy?
Not specifically, but yeah, go on. I may have.
I think it's their example is generate as many paper clips as you possibly can, and then like the story is like the AI destroys the electrical grid to get more metal, and then like it generates all the paper clips. But yeah, that's interesting.
That's like I think that's been a general. I feel like that's something that's been mentioned before about like how AI could go wrong. Like you know, we have to be careful. So instead of a Terminator style thing, instead you have this AI that's you know, it seems like it's optimizing for something good, but then it goes about it in a totally unexpected way, and then you know that's how it ends up killing everyone or something. But yeah.
Yeah. It's like accidentally did something to optimize for its objective, and you know, incidentally killed humanity in the process.
Yeah.
But to your point a second ago, sorry, quick note on the mainly just support for what you're saying, Kevin. Like, can you make something? Can you over red team something or make something too cautious? Like, I use this analogy in the software development like realm, like from like a product management perspective. It's like, oh yeah, the easiest product to support is a product we never release. And so like if you're worried about like you don't have to support any bugs at all if you never release a product. And so that's super happy for the engineers, but at the same time you've provided zero value. And so that's where I think it's like, if you're constantly if you were typing in like, oh, how do I change this line of code, and it's like, oh, well, this might be a piece of code that was in this library at some point 15 years ago, and so therefore I can't respond to anything that you say because there might be some copyright limitations. Like if it's being overly cautious, then it's just not useful at all, and so therefore it's providing no value. That's not to say we shouldn't be doing red teaming. That's not to say we shouldn't be being very cautious and of like copyright infringement and everything else. There's plenty of lawsuits that are going on right now on the OpenAI side that have to do with exactly that, because that is creative work that should be protected. But that's at least a situation where I think if it goes too far, then it becomes not valuable.
Yep.
That is very interesting. Yeah, that's new information to me. Like I'm learning a lot. So thank you so much for elaborating on that. I will move on to the next question now, since we have a lot. We alluded to this a lot of the course of the discussion already, but just to define what model hallucination is. Model hallucination is when a model generates incorrect information but presents it as if it were fact. So the question is, how big of a problem is model hallucination? Why is that a problem? Like technically speaking, like why does that occur? If you know the answer to that, and do you think that this can be solved anytime soon?
So why does it happen? I would say it's probably just because it's trying to predict. I mean, it's not a totally sound system in terms of, you know, the way things work. You know, if you ask someone how to add 2 + 2, it's not. I don't know how that works in our brain, but I assume it's not just like, oh, what's the next character after? You know, there's some sort of conceptual understanding, and I don't think these LLMs have that. And how big a problem is it? It is, I would say it's the only thing that's preventing these LLMs from just taking everyone's jobs, in my opinion, because if they weren't hallucinating, basically that would mean, well, you can trust them like 100%. And therefore, you really could just replace like software engineers or any other profession that's sort of in the crosshairs of these LLMs. Could actually be replaced, but because they're hallucinating a lot, we can't trust them. So really, right now they're just aids, and you know, they can't. They're just like co-pilots or whatever you want to call them.
Yeah, I think I take a weird stance on the hallucination stuff. Like to me, like when we think about LLMs and how they're trained, like they're generative models. They're just generating stuff based on some context, and how they were trained is just to finish the rest of the sentence, or like slot fill. It's kind of Mad Libs on steroids. And so when, to me, like the very nature of LLMs is hallucination. That's like the entirety of what they do, because they're like, oh, here are these 2 topics. Can you relate them? Or can you write Python code to explain I don't know, the song Bohemian Rhapsody. Like you can just like say something and it'll have a go. Like it'll take a shot, and it is hallucinating. Like the very nature of LLMs is hallucination. What's amazing to me is that it gets things right. is maybe the weird thing. So I take like almost an opposite thing. Like to me, LLMs are fascinating because they're kind of right more times than they are wrong, or because the hallucinations sort of make sense to humans. More so than like, oh, do they produce wrong information? Like if you worked with any of like even GPT-2 or early language models, not even large language models, it was just like a lobotomized parrot. You're just getting gibberish back all the time. It's just random words, or like, okay, I can see how that word's kind of related. Like if you're going to do like a covariance matrix of what words are commonly used together, but this makes no sense whatsoever. And there's some studies around this, like LLMs kind of just don't work until you get to a certain size and a certain data set size, and then they just work. And that's like sort of miraculous to me a little bit. But all that to say, like to me, the very nature of LLMs is model hallucinations. However, how much we rely on LLMs, I think, is the problem with like the model hallucination. So I kind of flip it. Like LLMs by nature hallucinate. It's us for us right now in the state we're in right now. It's up to us to figure out how much we should trust that hallucination that was just produced. And so that to me is where if you're an expert in something, LLMs can really elevate your game. If you know nothing about a topic, then you're trusting the LLM to explain this thing to you, and you're also trusting that it's not generating something that's completely garbage. You're kind of leaning in and just like kind of hoping for the best. So that's where, like, I say the writer-editor thing. It turned me from a writer into an editor. But if I didn't spend a lot of time writing before, then I wouldn't know what good editing looks like. And so if I'm trying to compose something that I have no idea about, then it can have the tendency or the potential to be completely gibberish and hallucinations. And we've seen this in like legal arguments where people have used ChatGPT to give them like cases and like, are these real cases? Yes, these are real cases. And it's like, no, they're just all hallucinated. They just seem interesting and support the argument that it's already making. So, but yeah, and there's some ways to bake in like some fact checking and those types of things in there. But yeah, to me, it's a weird one. I think about it almost in the reverse, that hallucinations are just the nature.
Yeah, that's a great point, because a lot of people like to say that just be cautious, LLMs are just noisy statistical models, and anything that you get out of them, like just take it with a grain of salt, because that is the nature of LLM. So I like the way that you put that. I like to say noisy statistical model, but I love lobotomized parrot. I think that is something that I'm going to start using, especially when referring to the older ones. That was great.
What's funny is completely anecdotal, but I got that. I asked ChatGPT to interpolate between this comedian I really like and explaining LLMs, and that was one of the hallucinations, as it referred to itself as a lobotomized parrot. And so,
wow.
So yeah, food for thought there. Interpolating between concepts.
That's so funny. So from the Q&A, we actually have a question about Pachyderm. So bringing it back to ML tools and techniques, what are the advantages of Pachyderm when it comes to developing LLMs? And that's probably for you, Jimmy.
Yeah, I can talk about this a lot. So Pachyderm, for anybody that doesn't know, so that was the company I was at before. It's also the open source product that deals with data versioning and data pipelines. In particular, obviously, data versioning is really important, and pipelines important when you're dealing with machine learning training and just even data curation, data set curation, everything else. So, so how does Pachyderm play into these types of things? Basically, when you're training models or when you're dealing with any type of model, LLMs are like really interesting because they use so much data and things kind of just normalize out of them. However, these data sets do change over time. And so knowing what data and like debugging an LLM, like, oh, it is already always getting these types of things wrong, going through those data sets and redacting certain things or updating certain information, or figuring out how you're tuning these LLMs with new data sets. Versioning those data sets, in my opinion, is A, super, super important. B, these data sets are really, really big. Pachyderm does some interesting things under the hood to deduplicate data. So if you have yeah, just like huge, like 10 terabyte scrapes of the internet, and only 10 bytes of it has changed, then you're not duplicating that whole 10 terabytes of data. You have like kind of it does it really intelligently. There's like some massively interesting things that go on at the file system level. But yeah, so there's probably 1,000 ways I could take the question, but Pachyderm in and of itself is like built for versioning large data sets, and those data sets changing over time. With LLMs and just machine learning models in general, in order to make a model that's going to work like in practice or yeah, anywhere for any like real application, there's going to be development and iteration on that data. And so kind of knowing, if you don't know where you've come from, then you kind of have no ability to know where you're going. It's like if you're trying to, well, more or less, if you're trying to develop software without Git or without any knowledge of what your software looked like, you only have the most recent state, that you're going to be in a rough spot for collaboration and all kinds of other things. I mean, shameless plug, and I put this in the chat as well, but yeah, I'm doing a talk that like heavily digs in on this tomorrow. So from crisis to clarity, ensuring reproducibility is the talk. So yeah, if you want to really go deep on that, definitely check that one out.
Awesome. Thanks, Jimmy. So I think we only have a few minutes left in the session. So if anybody has any more questions that they want to ask, definitely drop those in the Q&A or the chat right now so I can fit them in. I'll wait for a minute or so.
I'd also be curious, like if for anybody that's on the call or anything, what other people like library-wise, or what things you're finding interesting these days. I'm curious, yeah, what people are working with, or some of the projects that they've come across that are pretty interesting. I'm always in search of fun stuff. I know a couple of people have dropped some things in, so thank you for that.
Yeah, definitely be curious to see. And yeah, thanks so much for bringing up PCs.app. Yeah, we got one question about what are your favorite LLMs?
Favorite LLMs? This
open
is
source ones.
Yeah, I was going to say shamelessly, like I use the OpenAI ones a lot, which aren't open source, which is definitely a negative. But as far as quickly prototyping or messing with something, I think it's really useful. Just get an API key. This thing works. I don't have to worry about infrastructure, setting up infrastructure and all that. That being said, I do use the Llama models, the Llama 2 models a lot. I use the Falcon models quite a bit when they first came out, but it's moving so fast. There's like always new models, and messing around with them has been a lot of fun. But then it's like, oh, okay, do I need to download another 40 gigabyte model and make sure that, and see how well it works with this particular problem?
Yeah, I've only been using ChatGPT, and I'm paying for the ChatGPT 4. So definitely worth it. But yeah, so it's not really in the spirit of open source, but yeah, I'm just not sure. Like I haven't, so there's Llama and those things. Is there a really easy way to interact with them? Is there like a nice like repo for, or is it more you got to get into? I mean, I'm technically capable, of course, but
yeah.
It's just ChatGPT is so convenient. Right?
Yeah,
that's how I feel as well. Exactly, Kevin. Is it LangChain one of the tools you can use to interact with them, Jimmy?
So LangChain is more the wrapper, like, so you can say run this model, but then you're still having to spin up the infrastructure under the hood. Like you have to have like an A100 if you're going to run one of the bigger models at least. And having that on like your laptop, probably not a thing. But if you're using a cloud instance, then you're fine probably, or you have the capability of grabbing that. But yeah, so like LangChain is more just like the glue code. There's like the scripting on top of it. Someone put like the Hugging Face has a chatbot for Llama 2. Hugging Face is how I interact with most all of these anyway. Is yeah, Hugging Face, like download this LLM or run this LLM and then predict with it, and their spaces make it really easy just to like kind of interact with those models at a high level, but then yeah, if you're trying to do something super powerful, you want a more robust installation, is my experience. But yeah, and then again, something I'm actively working on right now.
Yeah. All right, so we are right about the end of time. Do you guys have a few minutes to stick around to cover a couple last minute questions, or do you guys have meetings?
I've got a couple minutes, yeah.
Okay, great. So yeah, if you guys want, if anybody in the audience wants to stick around to talk a little bit more, feel free to stay on. We'll just cover a couple more questions here. So somebody said mixing LLMs with robotics is a big discussion for my lab. Oh, do you already answer that? Oh, papers, okay. We see many papers chasing the hype, but it does look promising. GPT-4 can get us somewhere, but we should tread carefully. There's actually a question that I had lined up about GPT-5. So do you think GPT-5 is going to be an incremental improvement or a leap? And what capabilities do you think it might have? And I know this is speculative, so just we'll take your answers with a grain of salt. I know you don't like to speculate, Jimmy.
Yeah. I'm maybe overly AI red teamed in my own brain. So yeah, no, GPT-5, it's hard to say. Like I still haven't really messed heavily with like the GPT-4, including images with the text and everything else, which was one of like the promoted features, at least in their non-technical white paper, I guess, that they released. So GPT-5, I mean, tons of speculation. Is it going to be like 10x the parameters? Is it going to be, 10x the amount of data that's gone into it, or other types of things? And to me, it's just really hard to say. Like, I would love for it to just be, 10 times better in every way and solve a bunch of problems that I have on a daily basis and make my life so much easier. But I have no idea. It could be. I mean, I would expect there to be more parameters. That seems to be the trend. I would expect there to be more data. That seems to be the trend. Things have trained for longer, and some of those types of things. It's going to be better at all the different tasks that are typically measured, and probably say like, oh, if you're taking the bar exam, then it's scored with the top 1 percentile now instead of the top 10 percentile. But what that actually turns into, I think is going to be kind of interesting. I wouldn't be surprised if they also incorporated some level of like speech into it. To me, that would be a super logical thing. Right now we're typing stuff out. Why not just talk to it? And they also have, at least OpenAI has plenty of models that do that. So those would be like some of the high level things I would expect. If they've already started looking at like the images and maybe some video stuff, why not speech in there? Why not just talk to it directly and actually have the AI assistant rather than, ChatGPT?
Yeah, it's funny you mentioned that, because we still don't have access to the image functionality for GPT-4, even though it's capable of that. So
Yeah.
I wonder if they'll add speech, and by that time we still won't have access to the image capabilities. So yeah.
That stuff,
Just
when you have like the image or like being able to talk to it or something, those are like separate. These are like different components, right? It's not one giant model, I assume, right? So
I think it is, and
really?
it's like a different what is it? Input encoder, I guess, for the images, but it's embedding into the same like space, or like the model is still like massively big. There's like an encoder that's doing certain things for the images.
Okay.
That's kind of auxiliary, but it still goes into the same model because it's still predicting a textual output.
So it converts it takes the image, it's like image to text or something, and then the text goes into the usual GPT model, maybe, or something.
Yeah, sort of. Like, for instance, one of the things that they showed was, here's a picture of a vending machine. What number should I press to order a Coke, or something like that? So like those types of things were, at least in the demos, but
Impressive, yeah.
Yeah.
Okay. Yeah,
Capability is different from, like lab conditions.
Right. Yeah. Yeah, I think it is really hard to say what it's going to be able to do, but I'm gonna be a contrarian and say it's going to be an incremental improvement, just because I just think things tend to go that way. But yeah, so even if you have more parameter, I just wonder if there's like a limit to just being able to, if you just 10x the parameters, how far can you keep doing, how long can you keep doing that for? And I'm also kind of hoping. So I also think there's still going to be hallucinations, of course, and I am kind of hoping, if the thing is, if it goes 10x better, I think there will be societal problems. So I'm just hoping it doesn't improve that quickly, because I think it is going to be an issue just in terms of like, I don't know how people are going to adapt. Maybe people will just kind of keep doing stuff, and even though these LLMs can kind of replace certain jobs or something, I mean, if it really were going to be 10 times better, I feel like it's going to start having an impact in that sense, like a big impact. And I think we need to figure out what to do about that.
Yeah, we didn't even get into some of the societal implications. Well, not very. Yeah, that becomes a whole nother Q&A session, I think.
Yeah.
Yeah. All right. I think we can start to wrap it up here. But yeah, this was a great discussion. Thank you, everyone. Thank you to the audience for all your great questions. Definitely join us in the community Slack if you haven't already to ask more questions. You can definitely engage with us there. Just any final thoughts from either of you, Kevin or Jimmy, to wrap up this session?
Any final thoughts?
I can also ask a provoking question, whichever one you prefer. But yeah, if you have any.
Yeah, if you can ask a question, I don't have any final thoughts.
All right, cool. Let me find the spiciest one on our list. Let's see. Or let's do this one. Do you think neural networks are the path to AGI, or do you think that some other technology will be needed?
Some other technologies can be needed, I think. I think there needs to be some sort of biological component. Oh yeah, here's one way I was thinking about it is if you have so I don't know if AGI needs to be conscious, but maybe let's say it does need to be. Maybe it doesn't, but let's say it does. I don't think like a neural network in a computer, in GPU or whatever, I don't think that can be conscious, because I was thinking, the equivalent, what you could do to replicate a transformer like a GPT is you could write all this down on paper and like do all the calculations yourself. Like it's possible. It would take a long time. There's a lot of calculations, but you could do it with pen and paper, and you would come out with the results. And therefore, you're kind of like replicating what the model does. And is the pen and paper conscious? No. So, that's my argument for why that's not. So I think there might have to be some sort of biological component, to get something that's going to be truly, on the level of, in terms of like being able to really think about things like we do. But yeah.
Yeah, I guess it depends on what you define as AGI too, which is why this one is a spicy one. But yeah, I'd love to hear your take, Jimmy, if you have one. I know this is definitely in the realm of speculation, but so why I saved it for the end. But.
Well, then I'll try to be spicy back and say my hot take is it neural networks or something else? I think we'll likely basically do something that's not AGI that will kind of wipe out some markets. I'll be a doomist in this scenario. Wipe out markets or send us back to the Bronze Age, or like bring down all of infrastructure before we get to AGI. And that's probably my hot take there is I think people will cause some issues before we get to anything that like resembles AGI. We'll use it for evil rather than good long before that. Is my rough hot take. But then I think it gets really like something capable of human intelligence, and then the argument from like superhuman or super intelligence, the Nick Bostrom book. I don't know if you've read that one. Really interesting, but basically it's like if we can create something that's capable of human intellect, then it will automatically become superhuman because it has access to more compute, which is interesting. But it takes a very naturalistic view of things, that like there is nothing like the quantum stuff or anything like that, that everything follows exact logical process. And I don't know that I follow logical process here necessarily. So it's a, I think it gets into some interesting physical considerations with regards to that. And I'll be very open-ended and ambiguous about what I'm saying there, just to leave it spicy.
Awesome. Yeah, this is a great end to the session. Definitely learned a lot. So thank you both, Kevin and Jimmy, for all of your great insight. Thanks to the audience again for your questions. And we can end it there. So thanks everyone for joining. And I think we should definitely do this again. This is super fun. But yeah, thanks everyone. Have a good one.
Thanks, Isha.
Yeah, thank you.
All right, see ya.